more boring of the two presentations that are going to happen in the same time. We're going to be talking about the Redis MCP server, which is something quite new that we're working on together with part of the team here. Vital part of the team that's actually building it still hasn't arrived, but he would be here to answer more questions if you have, because I have a fairly good understanding, but the expert is he. He's the expert for that. So, first of all, my name is Tihomir. I've been working for quite some time at VMware, where I was doing a lot of different things, mostly focused on UI, but also backend and full stack and whatever was needed. Then I switched to Redis 2 years ago, and as part of my job there in the ecosystems, clients and ecosystems team, I'm working on the contributing different features to the ecosystem. Before that, I started by maintaining the open source Lattice driver, which is a Java asynchronous driver for connecting to Redis. And very lately, we've been contributing to LangChain and to Nathan as part of the AI effort that we all love and like to hear more about. A huge disclaimer, and I'm obliged to say that, most of the things are in incubation right now. The MCP server itself hasn't yet reached the version 1 state that we would like to have soon. So things may be changing quite a lot in the coming days and months. This is the agenda that we would like to cover. I assume that most of you have some prior knowledge about how AI basically works, generally works. We're not going to have a deep dive there, but I'm still going to have a few slides on what is MCP and what are agentic flows, just to make sure that everybody in the room is having some basic knowledge that we can step on, and then talk about the details in the Redis MCP server. Then I'm going to show you two major ways of using the MCP server. One is for improving your developer experience, and the other is as part of agentic flows that you may want to write or your software might participate in. And I'm going to mention briefly how other products in Redis are also exposing MCP interfaces as part of what they're doing. You may notice that here and there stuff would be duplicating itself because obviously we're still figuring out stuff. Like the whole MCP protocol is quite new, and product is still attempting to find the right place for all the features, and there are some overlaps here and there. But we'll be mostly focused on what you can do right now. So what's MCP? MCP is a protocol that you could use to have a standard way to talk to your external tools from the side of the LLM. So if you're using Claude, GPT, Llama, these are just examples. It could be any type of large language model. Agents that are participating there used to talk to other tools like, again, just for illustration purposes, here it's GitHub and Drive and Slack, but you could just put anything there. Before that, before the invention of the MCP, they would all have to duplicate the unique API that each of these services exposes so that they do stuff with it. Like if you ask your ChatGPT agent, because it has to be an agent in order to do stuff, if you ask it, please check my mail, it would have to use a specific protocol depending on what your mail service is. With the invention of MCP, this became a bit more standardized. You have a protocol, it exposes certain tools in a certain way, and allows you to have this abstraction layer between the two parts and make it much more easier to talk to these external tools and do agentic stuff. We'll talk about agentic stuff later if you don't know what it is or like to refresh your mind. It uses JSON RPC for communication. It's bidirectional, so you could also send from the MCP server, you can send push messages to the agent. Like, for instance, you may want to refresh the list of tools that you're providing there, and you could do that without it having to query you for this. And that's like a very brief overview of what MCP is generally. And I can also tell you a few stuff about agentic flows. It's a very complicated thing that I'm going to try to explain very briefly, so I'm bound to say stupid stuff. Sorry about this. There's a very nice paper here mentioned in the bottom that explains all the pitfalls of creating agentic flows right now in the industry. It's a bit dated, by the way. It's to 2023, I think. But it still outlines a few issues and obstacles to make it better. Basically, what an agentic flow is, you have some software, which we call agent, and you would want it to do something. So you put a prompt there and say, what can I do in order to get this software to talk to this service and send data to this service? What the agent does is it queries the LLM and asks it to build up a list of things that it needs to do in order to achieve the goal. So you have an overall higher goal that you're aiming at, and you break it down into different steps. You, like tasks, you put it in a list of tasks, and then again you do the same thing. You start the flow from the beginning, and you ask, what do I do to do this specific step? Until you get to the point where you actually could use tools. So the tools would be the actions that you take in order to get to the goal. And you could utilize multiple tools to do your specific goal. It could be just one tool, depending on what the LLM says. And it could be something really bad. It could be something really bad. Because, you know, AI is not perfect, far from perfect. So you have the option to allow it to do it by yourself, or you can approve each of the steps needed for achieving this task. Most of you have used it, but I'm explaining with more detail just to make sure we're on the same page. In this whole picture, MCP is somewhere here in the tool, the act part and observation part, because observation is the result from the tool. Like if the task that needed to be done resulted in an error, the LLM needs to correct itself, the agent needs to correct itself, and obviously it needs to take this error, send it to the LLM, say, okay, I tried this, but it failed, and then do corrective action. Just put another task in the list before continuing forward. Very, very simple explanation for something really complex, so I'm bound to have skipped stuff. I'm only explaining from the perspective of the MCP so that you know where it stands in this agentic flow. And this is a very, very crude, just to give you some idea, picture of these things that go around the JSON RPC when the MCP server and the MCP client, which is the agent, talk to each other. So usually they start with a tool discovery. So when the agent first talks to the MCP server, it says something like, okay, give me a list of the tools that you're providing to me. And I think this is the reply that I've showed there. Sorry, it's not very obvious which is a request and which is a reply, so I'm going to give you context. This is the reply to the discovery, because the request itself is just a couple of lines, give me the tools. And this is the reply, so the server says, I have a tool that's called calculate arithmetic. The title is the friendly name that could be shown to the user later. What it does is it performs mathematical calculations. What it needs to work is some sort of a mathematical expression in the form of a string, and it's a required parameter. You could have many parameters. This is basically you're defining your API contract from the perspective of the LLM. The LLM needs to know, the agent needs to know how to talk to you in order to fulfill the two's usage pattern. Then when the user actually inputs a prompt, the agent would ask how to do that, and if one of the steps is you need to perform a mathematical calculation, it would match this. You know how this works with a vector similarity, and seeing the description, it would know that these two would work. Now, a very reasonable question is, what would happen if you have many twos and some of them define the same contract? And the answer is, it's unpredictable, so every time it would be a different thing. But this is how it is right now, as far as I know, of course. You're all folks here are very welcome to correct me, because this is very novel and some of the things are maybe changing. This is what I saw last time. I was wondering what will happen if you define a very broad contract and say, in order to do whatever, just go to this tool, and it kind of worked. I mean, it went there most of the time. Sometimes it went to other tools too, depending on, you know, vector similarity. So the request is, yeah, I know that you're doing this, so please do that. In this case, it requires us to get the current weather, and it provides the arguments which are required, location, and probably the units are not required, but they still would want to have, for some weird reason, Imperial. I would not do that, but I'm a European. And then the response is, obviously, again, to this same request. This is a text response, and this is the weather in San Francisco. And this is the whole flow that you have here. It's very simple, but it could be used to do some very complex stuff, which I will demonstrate later, hopefully. And again, this is LLM. So we are going to see a different version of what I tried yesterday when I was trying stuff up. So some stuff might not work, but generally, we want to get the picture. So how does Redis come here? Well, one of the things that our team decided we could contribute in this flow with is to provide this MCP server, which stands as a LLM contract in front of your Redis database. One of the biggest advantages that you have right now is that you are having a very good contract, confidentiality contract, or whatever you call it, in terms of where your database is, what the credentials are, how you connect to it. If you would not use the MCP server, because you could, if you'd like to, you could use some other, like command line to Redis CLI, for instance, you would still have to provide the LLM and send this information to the LLM about where it is, how to connect to it, and you may not have the option for that. So one of the biggest, I would say, reasons to use it in the first place is that you keep your connection information, locations, and stuff like this inside of the MCP server, and don't have to expose it to the LLM. To the LLM, this is just a tool that says I can do Redis stuff, which is nice. But there's also different other things that you would benefit from, like a more clear contract, some more functionality, because it not only stands for the database, but it stands for the knowledge base. I'll talk about this later. So you could basically use it as a RAG. And I'll talk about this later too, what RAG is if you don't know. But you could actually say stuff like, how do I do a leaderboard? How do I implement a leaderboard? And it would provide you, the MCP server would instruct the agent that it knows how to give out such information using Redis, and it would provide you this information. And yeah, and of course, the obvious biggest reason that you could use it is you need, in your use case, to have a semantic way to query the database, because it's a different way than a normal API. APIs are strict. You use a certain framework, a certain protocol, and this also is strict and uses protocol, but it's the semantic approach. So it's a native to the AI flows way to connect to the database, because you might not have other ways to access it than this way. No, we get to the demo already. So in this demo, I'm going to show you specifically how the developer experience. Data access improvements work for the MCP server. Bear with me, it may take some time. But, so oh, sorry, I didn't finish, my fault. What I will use is IntelliJ as an IDE. You could use any IDE for this purpose. I'm using also Augment for the agent inside of the IDE. Again, you can use any agent that you would like to use. And of course, we need the Redis MCP server, which is installed in the agent. This is the flow. You need to install MCP server in order to be able to access it whenever you need to do stuff with it. Check, nice. So what we're going to do is we're going to ask a couple of questions to this agent, and the agent will decide, hopefully, to use our MCP server and show us the actual results. It's a very demo project that you try to ignore. It's really not very interesting. It's just used for demonstration purposes. So this is how we open Augment IntelliJ. You have here a tool. And we start a new conversation. And this new conversation ideally should not have any context for us to be sure that we are doing the same thing that we want to do. So we have the project here. Let me talk about the project. So the only thing that I want to have in this project is this model class. It would serve as a very good context to our demonstration. So it doesn't, I mean, details here are not important. But basically I've asked the AI to render a model for me in a Spring project that represents a Reddit article. And I would use this model to ask the agent to do stuff. For instance, generate a sample data based, oh, sorry, I can use it just here. So we want to do sample data. We want the agent to build up sample data for us and put it in the database. This prompt may not be enough, but hopefully, adding the context here. Sorry. Yeah, and one of the things that I've noticed is Augment does not play well with me when I'm doing demos. And here I would put the model name, the model class, just to make sure that the agent knows what model I'm talking about. Generate simple data based on my model in Redis, just to make sure it doesn't generate it somewhere else. And now what would happen, hopefully, is the agent would, not have internet probably. Yes. I'm sorry. Congress Center? Should I be worried about this? No. It should be okay. And we try again, this time with internet, because AI needs internet, obviously. Hopefully the agent will now see what it needs to done in a list of tasks. It would read the model to see what the model is. It would put it in its memory to know what it needs to do. And then it would query, you see here Redis MCP mentioned. This is the MCP that I previously installed. I'm going to show it to you. That was something I could have done. What it does now is it basically says, I want to set a JSON document. I want to store a JSON document in the Redis instance, which is pre-configured based on this model with some sample data. And because it's very thorough, it would probably want to know if the server is up and check if we had this done. It would eventually, and I didn't say how much data, so it's improvising right now. It may decide to do a lot of data. Last time it was 10 entries and it was enough. But, oh, Redis is not running. Okay. Let's see why that is. It started? Very smart, good boy. I hope it's the right server though. Okay, so this is a very good explanation. Now it gives me the option to talk more. First of all, it saw that Redis is not running, and it started Redis, but it started a Redis instance that does not have JSON, so it asked the LLM what it should do, and the LLM said, the model said, well, you should probably use then hash sets instead of JSON, and it's now doing a hash set, which is good improvisation, and it's not very important to us. What's important to us is that it's using again, the MCP server, and it's basically contacting this Redis instance. We'll see here. Yep. So this is Redis. I've opened Redis inside. This is the tool that you could use to check out what's in your database locally. And we can see now that these articles are added. I see 8 of them. So we decided to put 8 today. Okay, it's a good number. And you can see that it puts inside of it some interesting information just to fill in some data. So assuming that you had a task to have some sample data to test your functionality, this is a very good way to do it. You just go to your agent and you say, use this model, generate some data, and it tries to hallucinate the thing that is most beautiful for you. What else we can do? We can do stuff like, for instance, verify that there's at least one Reddit article in my store. Again, it would use the MCP server once it builds up a list of tasks to verify that. Well, to be fair, it already did that, so we're just repeating the same step, but I wanted to illustrate how it does it. It goes to the tool, it tries to fetch all the data. Probably not the best way to do it, but for our purposes, it would work. And then it says, yes, we have data, always fine, eventually. Yes, there are already articles in your Redis store, 8 articles, key pattern, and stuff like this. And yeah, I'm not going to show the others, but you could do some stuff like how many articles are there. I just imagined what would be interesting to a developer in that case, and you could have different questions about your store that would affect your logic or testing. Like if you're doing integration tests, you would like to verify that in a live database, all the fields are always filled and data is not missing from some of the fields. Or you would want to do some analysis. Whatever you want, this would help you to basically browse your data inside of your Redis instance. Now, another thing you could do besides the data access, and this is the demo, is you could also use the server as a sort of a knowledge base improvement. You know that all the models are built in a certain date at a certain point of time, and they need time to be updated again, which time they're not updated daily or hourly. And for the purposes of always having the latest information and always having the most relevant information, and of course they're not built on data that's not publicly accessible. So if you want to ask questions to the LLM that would require data that's not public to the LLM, you need to provide this data to the LLM so that it gives it to you. And this is where RAG, retrieval augmented generation, comes. It allows you to create a flow where you would still use the large language model as you would normally do, but you would kind of inject in your prompt more information coming from a specific source. In this case, what we do, our MCP server, and I'm sorry about the name here, Copilot. This is not Copilot, not the actual Copilot. This is how we code, for now, the server and chat that allows you to query the knowledge base of Redis. So what the MCP server does is when it registers a tool to the agent and it says, I'm knowledgeable about stuff about Redis, and if there's a question, you should know that you should ask me. And whenever the user prompts something like, how do I do a leaderboard with Redis, it would go through the Redis MCP server, it would ask Copilot, Copilot will query a smaller language model that we have with the vector store with our articles. It would find the corresponding article that you would want to have. It would give it back to the MCP server. It would give it to the actual app, and it would added in the prompt to the LLM. So it would say, aha, having this article in mind, how do I do a leaderboard? And it would form it in a very nice way. It's a very nice thing. I've used it several times, and it mostly worked, so we'll try to test it again. One of the things we want to do is, like, for instance, ask it how to implement a rate limiter. I know that there's an article we have that explains how to do a rate limiter, or a leaderboard, or approximate geolocation, and right behind caching. So all of these techniques are already in the knowledge base. So if you have the MCP server, and the MCP server this is a knowledgeable cat, this is why it's there. And the MCP server is installed on your environment, it would augment the data returned from the LLM with what we provide in the database that Redis has. So again, opening a new conversation, removing these just in case, crossing fingers as usual, not working because I can't select it. Augment. This is not a very good advertisement for Augment, I have to agree. How do we implement a rate limiter? Now, I assume it would, because it uses local memory, it knows that I've been asking questions about Redis. So what it did is it assumed that I want to implement a rate limiter with Redis. So it's now outputting how you would do it. I didn't specify a language or anything else, so the longer the prompt, obviously, the better the suggestion you receive. I'm just asking a very general question, so I'm receiving a very general answer with, I think, Python. But if we scroll up, you'll see that this is a very good detailed explanation on how to build a rate limiter with Redis and with Python in this example, I think. Yeah. So it works again in a similar way with all of the other questions that we have, like geolocation. How do we do a geolocation? You would ask it, right? Again, like this. And you will notice that it always contacts the actual MCP server. So this is the request to the MCP server. You can actually see, okay. We have some error that I didn't see before, but it would return again the data. And this is the two developer experience examples that we, sorry, this is not what I wanted to start, that we wanted to talk about. Now, this is the part of the work of the MCP server that's mainly focused on developer experience. Another thing that you could do, as I mentioned in the beginning, this is the second larger part. Well, not larger, but the second large part. There are two large parts right now. The second large part is you could do put it inside of some sort of an agentic flow that is larger than just a single call to the MCP server. In this case, it's a very, very crude example and probably doesn't make a lot of sense, but in this case, what we're talking about here is the agent is asked how to do a certain task based on several data sources. For instance, we want to rent a cheap apartment in Madrid or Toledo, and we want to know which of the two cities has a better weather. For some reason, both of them will be okay for us, and we want to choose based on the weather. And we want to store the data in Redis so that later on we can use it to make a reservation, because for some reason we require that. And in this case, there's several MCP servers involved, obviously. There's several different services involved. And in this agentic flow, you would have communication going all the way. And our example for that, did I miss something? I don't think I did. Oh yeah, that's the flow I missed. So in this flow, just to illustrate it, I think I explained it already, and it's kind of obvious, but what would happen is you would have the agent, the mobile phone is where the agent is, assuming. It would start like, in this case, we keep a session in Redis, so it would ask, the agent would ask for this session for some reason. it would get the session. This session could have like things like credentials for one of the services. You could put them there and not have to put them somewhere else. And it would then go to the weather MCP server, because obviously we want to check that. The order may be different, by the way, depending on how the tasks are returned by the LLM. But in this case, this is what happens. You go to the weather MCP server, you ask for weather forecasting matters into level, you get the information, then you find rooms in, well, in this case, obviously, you have to first go to the first one because you don't want to query both cities for options, but it may happen that it does it the other way around. Then it would search for rooms in the city that has the better weather, and then it would store the information in Redis as the tasks and the different services involved. For the purpose of our demonstration, we'll be using, we'll be using the Cloud desktop. Now, I forgot to show you, just one step back, I'm sorry about this. I forgot to show you what it looks like to set up MCP server inside of IntelliJ with Augment. So you have here the settings that you set up for Augment, and you have different types of services that are, because MCP servers, that's something I forgot to mention, I'm sorry about that, but MCP servers could be local or remote, either utilizing the STDU standard IO or using the streaming HTTP. So you have a list of services on top which are publicly available, and you could easily connect to them using some credentials. You could also add new ones or local ones. In our case, the MCP server right now is a local server, and to add it, you just input here something like, the example is self-explanatory, but you provide the way to get the server, how to start it, and how to call it. In our case, we have the UVX Python manager to download it from GitHub, and we have, well, that's it. The name is Redis MCP. In a similar way, if you want to use it in another application like the Cloud desktop, which is an agent, obviously, you have to specify the settings, and you have, in this case, all these things you're seeing here are changing very rapidly. Right now, in the current implementation of, probably don't see anything. So let me see if I can do something about this. No. Okay, I'm going to talk over it, and you're going to act like you're seeing it. But this is JSON, and these are several MCP servers which are described by their type of communication, standard IO here, the command that you have to execute, and the parameters that you have to provide to it to start it. And in our case, we have 4 of them. One is the Redis MCP server. We also have the Reddit server for some reason, which we don't need right now. Don't bother using this API key. I knew it was going to become public today, and it's going to be lasting only for a couple of hours. So it's just a temporary account that I have with AccuWeather, because this is where I get our data from for the example that we do. And we have on the bottom the Airbnb MCP server, which we're going to ask about prices and availability for our question. So you see the result here from the last question that I asked. It does the same thing. I'm going to see if today what it would return for the same thing. So we ask, find a room in Madrid or Toledo for tomorrow where weather is good, and store it in my local Redis instance. It would go to the first server, and it fails because the API key, I think, is no longer working. So it's reverting back to asking Google or some other search engine. It says, cannot access local variable location. Okay, so that worked yesterday, and we got from AccuWeather the weather in the MCP server. But the good thing is Airbnb works today. So we managed to ask the MCP server of Airbnb to give us information about Toledo, because the weather there is right, and we decided this is a good idea. And then we will save it in Redis. And I think it also failed, or no, it is. So yeah, that's an example. It doesn't make a lot of sense, to be honest. It's just demonstrating how this MCP server could participate in agent flows. You could, of course, use your Redis CLI for that purpose, but it has several caveats here. First of all, it needs to be installed, obviously, where the agent is running, which is not always possible. Another thing is you have to provide it credentials, which is also not very good in all cases. And last but not least, you basically have to cater this whole installation. And yeah, the next thing I wanted to mention after this demo is, unfortunately, I have to apologize to everybody here. I didn't get to actual demo here of Nathan with MCP. Nathan is a workflow orchestration server that you could run either locally or in the cloud. And you could define their flows that start from some point like receiving a message, or they're called triggers. So you can have different triggers for this. The two QRs, I promise they're mostly not viruses. The first one is the actual article in the Nathan documentation, how to use this MCP flow. The second one is a YouTube video of explaining that. By the way, if you're gonna do something, if you're gonna visit one of the two links, visit this one, because it will help you better understand how this works. And the guide there explains how this flow here, you receive a chat message, and you use the agent to do stuff like augmenting the reply with data from a service, or exposing a type of a search with MCP. What I wanted to do with this flow, if I had the time, and I'm sorry about this, was I wanted to do the MCP server, the Redis MCP server, exchange it as a node here, and make sure that whenever a message is sent to the chatbot, it would search in the database that's behind the MCP server, and it would augment with data from the search. So you have RAG again with data, which is augmented not necessarily with a vector search, but it could be any type of search. It could be a normal structured data search. Like you want to, for instance, you have in your Redis geolocations, and the person says, I'd like to visit Toledo, but I don't like the city itself. I'd like something smaller around it, like in 50 kilometers range. And your MCP server here, if it has that information, it could say, oh, Toledo, we have another booking that we can make for you, which is in some small town 50 kilometers close to it. And it would augment the chat message and the reply from the Nathan server. And this is the last thing that I wanted to show you. Again, I don't have a demo, but I'm going to talk a bit about it. Several times I mentioned agent and memory, a very interesting topic and very important for everybody that is involved in agents, in developing agents or working with agents, is how short-term and long-term memory is stored for an AI agent. Obviously, you could do partially some of the stuff with the MCP server, the Redis MCP server, but you have to do a lot of stuff yourself. What we have in Redis additionally is the Redis agent memory server. It's a dual-purpose server. It has both a REST and an MCP protocol interface, so you can query it with both interfaces. It doesn't matter. And it provides you with the ability to store data for the duration of the session, or the duration of like the whole persistent approach, where you know that this person would like to always search for vegan restaurants, and you store it in a long-term memory. Every time he is asking about, I want to go to a good restaurant in Sofia, it would fetch this preference from the long-term memory, and it would return it back to the LLM so that it caters the result based on this information. The short-term memory obviously is stuff that are conversational, they're part of this conversation, helps the AI look more human because it doesn't give out answers that make no sense, having in mind the conversation that you had with it up to now. Again, very interesting blog post, build smarter AI agents, managing short-term and long-term memory with Redis. That's by our colleagues Manvinder and Andrew. It's very interesting. If you have the time and interest, you should definitely check it out. It explains how this works, how to use the Redis agent memory and server, and how it fits in the whole picture. Finally, this is my experience with AI right now. It's a very sharp sword, but you could hurt yourself with it. So make sure you're using it in the right way. And that's hard because we don't know how it should be used right now. We're all learning as we're developing the whole AI ecosystem. But nevertheless, it's a sharp sword, so it could do a lot of interesting stuff and a lot of powerful stuff if you wield it in a right way. These are my contacts in case you want to reach me, or after the talk. I'm a bit faster than I expected, and I'm open to questions if you'd like to ask me something. Thank you. Yeah, so I'm going to repeat the question so that everybody hears it. The question is, how do we distribute these pieces of software, and how do we handle security in regards of credentials and secrets, I would assume. Now, the current way that we do, let me start from that, the place where we're basically seeing new ways of distribution as we speak right now. Just a couple of weeks ago, a new store kind of was opened, where a new format in which you can package your MCP server was advertised. Several have already died out, like Smittery, for instance, or at least changed their purpose. So it's a very changing topic. There's not really a single approved or way that everybody agrees on. But right now, in most cases, they're distributed like a, because most of the code is written based on the framework it's written in. For instance, the MCP server that we developed is written in Python. So there's several frameworks that are very popular for Node.js, for Python, Java not that much, and they are distributed in the same way that you distribute an application written in the ecosystem that you're writing in. So for Python, that's PyPy, for instance, or some other way that you would provide. Like you could basically, my demo was pulling the MCP server from a branch in GitHub. Not perfect, but it does what I wanted to do. And there's a way to package them depending on different providers that would help you. Help me here. What was the name of the latest one? The packaging, the packaging that you could do to get in the store of, was it Anthropic?
It's already listed on Gemini.
Gemini.
Of course, yeah. And also working to list it on, there is GitHub registry also.
Yeah, there's GitHub registry, there's Gemini registry. So there's different ways. I don't think we sign it.
Not yet, yeah, but it's listed as a trusted. So basically,
Yeah,
the registry itself.
we give it to them and they said that it's okay. So it's very secure. Credentials, obviously, this is one of the purposes we created this in the first place. You keep them, there's different ways to provide the credentials to your MCP server, and it's a bit up to you which one is most safe in your organization. It could be an environment variable, it could be part of a configuration script, it could be provided to the process as a parameter, so different ways, but ideally, would the user know what he's doing, he is able to secure them in a way that they don't leak. Does this answer all questions? I'm going to come so that I can hear you. Okay, I'm going to repeat the question again. The major question is, are there concerns and how do we handle speed when we compare communication through REST and from the MCP protocol? Just to correct you, this is not an agent that I showed, it's an MCP server. Again, the agent, I don't think we have an agent in Redis.
No, I actually mean server.
Yes. Yes. So again, for short-term memory, the memory server has two options. Unfortunately, I can't talk a lot about it because I don't work on it, but I'm going to give you a brief, an uneducated answer to your question, I would say, because I haven't actually tested out speed. I assume that usually when a person decides to use the MCP protocol, they are not really concerned with throughput and speed, because the MCP protocol is, I mean, you saw how fast it is when you use IntelliJ. It's not really fast. If you want to have speed and throughput, you would model your whole system in a way that would be more performant, probably with REST. But having asked this question, this would still be slow if you want to do it. If you want to take advantage of Redis with its high speed, probably another interface, like a REST interface, and some sort of binary serialization of data would be much faster. Again, it really depends on the use case that you want to serve, because most of the use cases here are conversational and thus inherently slow, and you don't really benefit a lot from the speed. You benefit more from stuff like, because you have two aspects here. You have the speed of communication with the server, which is one thing, and you have the speed of processing of the query that you gave the server, which is another thing. So eventually, if what you want to have is a fast way to understand, like search some data in Redis and use the capabilities of the Redis query engine, you would still get the performance of the Redis server, but you would have to, accept the slow MCP conversational part, because if this is your flow, you have nothing to do about it. It's just how it works.
That's fine. It's clear. Thanks for the speed part. And what about the throughput? Kind of same.
Yeah. Thanks.
What about the throughput part? I mean, because when we use Redis when we have multiple, very many conversations at a time, very many sessions. What about the throughput part? Are they the same or not?
I would say that it's not really optimized for large documents and throughput. Again, because it's more of a supplemental part to the, you would basically have a lot of context to pass around. And you know that if it's used for RAG, one of the consequences of using RAG is that you're extending the context window of the prompt that you have. So you can't do that indefinitely because you get a huge hallucination based on your prompt. And that's the limitation of the technology right now. But again, I'm talking here very broadly. It really depends on the use case. You may do, as with other stuff, you may do one thing in several different ways. And depending on the way that you choose to do it, you may get more throughput as a result. But I would not use specifically the MCP servers for throughput or speed. That's, at least right now, what I see, that's not their power. Any more questions? I can open. Yes.
Yeah, you mentioned about the long-term and short-term memory, and I was wondering how do you decide what kind of information to save in the short-term memory and what kind of information to save in the long-term memory?
Again, it's more of a question to how to build an AI agent flow, let's say, agentic flow. Based on the purpose of the system. I can give you a very general explanation of it, but based on the purpose of the system, usually you would use short-term memory for stuff that is part of the same conversation or the same prompt also, because this type of short-term memory, it does not participate in later interaction because, again, we'll build a too broader context window for the initial request to the LLM. It's more like, for instance, the steps that we described here for finishing some task. You have the session of the prompt as the time that this information is limited to. In our case, like if I ask the agent, can you prepare some demo data and put it in my Redis instance? It would go to the LLM. It would ask, what should I do in order to prepare demo information for this model? And it provides the model. And then the list of tasks that the LLM would return would be very good candidate to a short-term memory, because this list of tasks you don't need for the next prompt, obviously. You could extract some information like if you ask the user, if the agent asks the user something like, do you use Redis as a database? Because it does not know initially. And you say, yeah, please use Redis, then this is a candidate for the long-term memory. Because again, when another prompt comes, today, tomorrow, or some other time, it could assume to use Redis based on your long-term memory. It's not perfect, obviously, because you may be using Redis just for today, but this is the state that I know of. One question here.
Yeah, if I understood correctly, currently you're running the MCP server locally on your machine, right? Are there any plans for it to be publicly available through the Redis cloud or some other way?
You're supposed to ask easy questions.
Sorry.
Yes, currently the state of affairs is that we are distributing, as I mentioned, the server with PyPy, and or you could use it from GitHub, whatever, and it only uses a standard I/O for communication. It's a limitation for now that we want to change. First, I think we're going to start with a streaming HTTP as a first step. You would still have to host it yourself, but it will be available through HTTP, which makes it easier for you to start a Kubernetes container somewhere and it being like a service in your environment, but still local. And eventually, but again, we're not making here commitments. This is not a commitment. Eventually, we will probably want to have a service, especially for the cloud, because Another thing you could use this MCP server for is you could have a connection to your cloud instances for Redis, and obviously a cloud service that acts as an MCP server for cloud Redis instances makes a lot of sense. But for now, we don't have a clear roadmap for it. We want to have it. If somebody wants to contribute, because Redis is open source, don't listen what people say, it is open source, so you're welcome. Any more questions? I can talk about how flooding your apartment slows you down to prepare your presentation. This is one of the things that happened. Well, if not, thank you very much.
Не знам, тая картинка ще я махаме. Или... Окей. Сега борбата ще е голяма с дисплеите днеска с моя компютър. Целим. Така. Все пак искам и аз да виждам нещо, ще го направя по този начин. Alright. I will speak in English for this session. We'll try. My English is not the best, but I'm close to the monkey, so it's normal. I was planning to do something really deep here in this session, but I just decided before it to present it on the slides instead of technically on the servers, just to not risk to fail down again. And yeah, what we are talking about today, zero downtime Postgres upgrades. Every one of us knows that software change every year. If it's not changed, the bad people are trying to, let's say, compromise it. And these upgrades are mandatory because without them, we are risking not only systems, but also businesses. Postgres is developing really intensively, and every year they produce new software version. What that means, we should be prepared with upgrade planning really strong. And plan the upgrades year over year, so it never stops. What is the problem with this? During the upgrade, we have downtimes. Even in cloud, where all the businesses are going, it's very modern these days, we have downtimes. And downtimes can be from 20 to minutes to 2 hours, and some applications could not accept this, meaning they have live customers, financial transactions, and a lot of mess can happen if you go down. If you are into the business, you know how bad it looks if your financial application is down. And yeah, traditionally we do upgrades even in the cloud using strategies that result in these scenarios. Dumping and restoring, cloning VMs, etc. And up till now, up till version 17, after each upgrade we should also update our statistics, because we know our databases needs to be aware what they contain, how many rows are in the table to produce the best execution plan. And Postgres has this luck. They do not move statistics automatically between the versions. This results in another period of time, maybe it depends on the size of the database, where our data may not be available for our customers. Now on the screen is the normal upgrade process. It differs between the architectures, between the providers, between the setup that we have, on-prem, cloud, whatever. But in general, this is what happens. The new version is once installed. The data is, the applications are stopped, the data is moved or upgraded in place. If you have new cluster, you start the new cluster, then you update your statistic, then you stop your new cluster, and it's multiple times during this process that you result in outages. And you cannot accept your applications working on top of this unstable database environment. But without data, as we already know, your application means nothing to the customer. This year, 2025, Postgres did huge step by implementing a strategy inside the engine to move statistics together with the upgrade. Meaning, if you upgrade your instance in place, your statistics will be transferred as well. And this results in less downtime and less scenarios where your execution plans go wrong. How that, what that means when you are in the cloud, you may save money. Why is important? Because when you have unoptimized plans, your CPU can go crazy, your storage can go crazy, your memory can go crazy, and if you have a bad designer that chose to auto-scale your database instance, your build can go crazy as well. So this step in the part of the statistics is really important for the new version, and I believe this is why we are stepping really hard in front of the commercial RDBMS systems. Who will win more deals? This is what it means. So for today's session, just for you to be aware, I did these slides 40 minutes before the event. So it's a little bit stressful to present without preparation, but this is how it works. Even in the business, when you're on the field, sometimes it's stressful, so you need to be prepared. And our mission for today, for this session, is to upgrade Postgres version 13, which is already outdated. It's not supported anymore. No further patches will be produced for it, to version 16 or 17. Why not 18? Because on the environment that I am working on, and most of you, version 18 is still not available. It will be maybe in the 6 months elsewhere. But nowadays, the most common versions are 16 or 17, to which we are upgrading. The goal is to do this with almost no interruption, but almost means completely invisible for the application. And that's possible, yes, even in the cloud environments. It's an option. We can design to achieve zero downtime upgrade with multiple, let's say, software configurations. Our Postgres instance from the source should be read and write, available for reads and available for writes. And lucky enough, we will have rollback scenario, something that you don't have on cloud providers, or you don't have it by their solution. Of course, I tested this on our SAP BTP platform. It succeeded. I'm not able to present it in front of you like really live, but I'll go across the slides and explain what happens in behind. And behind the scenes, there is a lot of small steps that were implemented, but we achieved finally a great result. So our source DB will be version 13, target DB will be version 17 for this. We will be using PG Bouncer, integrated into our application, or it can be even started on SAP BTP platform as an external service. So you can not directly connect to your Postgres instance, but go through the PG Bouncer, who has really nice features like pausing the transactions for 30 seconds, redirecting the traffic and doing a lot of magic as well. So PG Bouncer also controls your sessions in a manner that they can be kept alive. It will help us to reduce the downtime. But of course, only PG Bouncer is not the case. You still will have short period of time that your database will not be available. Because we are on BTP platform, we at the hyperscale service limit your logical replication options. Usually, if you design on-prem system, you maybe chose to have active and standby server, mirror the data through a replication, and when it's time, just switch over to the new system. But we limit that parameter, so we do not allow you to do that for many reasons. Of course, in heavy costing plans, you have it. So to achieve the zero downtime scenario, we put one more component in place, and this is the Redis cache. What this part will be responsible for just small period of time, all the sessions to be kept in this cache and just not result in dying for the application. So whatever happens during the upgrade, during the instance that we are stopping, starting, whatever, these sessions will be kept in the Redis cache and will not be reported as closed for the application. So this application, maybe you will see a circulating window, or it happens all the time. You maybe lost the connection for the internet for a few seconds, but this doesn't cause the customers to refresh browsers or whatever. So let's go forward. This is the design that we are heading for. It's very simple. Our applications can be deployed in SAP BTP platform with many instances. What that means, you can move loads between multiple instances, and you can, let's say, achieve blue-green deployments by having this. 3 or 4 instances can act like splitting the load or just covering instance that goes down, whatever. We are not going deeply into that part because I'm DBA, not the application developer. But yeah, that's an option in our platform. We will be doing connection to the Redis cache for keeping keys for the sessions in this cache. And we will be having PG Bouncer that will control where actually we are connecting to the source DB or to the target DB. And because we are limiting the logical replication, I chose for this scenario PG Loader with a flow option. What it happens when you use PG Loader? You can move data from your source to your target, and you can track the changes from the source and apply to the target real time. So you do once initial load, then you start it with flow option, and you trace changes that are happening here and apply to the target database. Of course, if you do it at 8:30 in the morning, like we did today, it is going maybe to not be the best time to upgrade your instance. You will never be in sync. So you prefer to do that part in period of time that your applications are not so heavy loaded. At some point, they will go for completely equal, and yeah, this is the time where the magic actually happens. So let's go. It's easy like this to create Postgres instance in BTP environment. You create your account, you subscribe for a subscription, you choose a plan, and you just execute this command or click two buttons from the cockpit and you have Postgres available. You can have many versions. You can also create the same way and the Redis cache instance. And the best part of this is that you're not restricted to use only one cloud provider. You can do it on today 5 different providers. One of them is SAP itself. So you can go to Amazon, Microsoft, Azure, which I personally do not recommend, as always. And you can go to AliCloud, which is if you have China restricted data, or Google Cloud, which is still going very good. Just from experience, the most comfortable environment that I'm working with is Amazon. So just to mention here, the joke for the Microsoft is not because of their cloud is bad, it's because like a person being in Oracle for 12 years, I don't like Windows, so everything with Microsoft is a joke. It's not something that you understand maybe in the wrong way. They have good solution for Postgres. Okay. After we created our instances, let's imagine, because we cannot show it now, it's already 20 minutes past, so if I needed to do all these steps, it could take me 3 hours to upgrade. So I decided to go faster and just go through the slides. So next step, the PG Bouncer setup. You can integrate your PG Bouncer directly in your application. Let's imagine it's Java application. You create a script that starts the software locally on your virtual machine. You put your script into the manifest file, and once you run your Java application, the PG Bouncer also starts. And your configuration now will not point to the database host and port directly. It will point to the PG Bouncer, who is responsible to split the traffic at some point. This is important because you can host it separately or you can integrate it into the Java app. And if you are a developer, you should think about it. When you design your system, you need to think about scaling it up. When I built my first website, I had 2 users. 2 weeks ago, 2 weeks after, I had, let's say, 3,000 or something per minute. And it wasn't a really nice feeling, to be honest. It was down all the time. So when you design, you better think about scaling up, which our platforms allow. And you can also think about doing some magic with PG Bouncer to help you control the load. So, next slide. It should be executable, yes. The script runs locally on the VM. It can be running behind the scenes, and when you integrate it into your Java runtime, it's a completely achievable scenario. This is how the configuration file looks. I'm not going deeply into this, but what's important here is that you have on your Java application PG Bouncer starting and Redis cache integrated. So your sessions may go through the Redis cache when needed. You can control on this one. And this is what we are going to do. This configuration file now points to our Postgres old instance, 13. And later, we will change this to our new instance, 17, by just rescheduling the application with one simple command. Okay, we said that we are going to use PG Loader. PG Loader has configurations that can be different based on different scenarios. This one is sample here. And this one do actually set concurrency, number of workers, 8 in this example. What we are migrating, do we migrate data only, or we keep other data models also migrated? It captured the create table and create index statements, meaning if you create new table during the load, it will be transferred as well. And yeah, you do not drop any table, meaning if during your load you drop a table, it will not be replicated to your target environment, so this table will be there. But from experience, I don't know actually, maybe some people do stupid things, but from experience, when you do migrate databases, it's a really controllable window and no one touches something else in the database. Drop tables is not something that you do during the migrations. Or not something that I would do. Okay, so we first copy the main set of data once, then capture the state, and then start with a flow option, which is inside this configuration file. It's not in the screen, but this is -- flow, and that starts tracing your changes and moving them to the target database. During this period of time, your users are connected to the old instance version 13. They see nothing regarding this migration and this data moving. And you can keep it for a long time until you are completely sure that you are ready to switch to the target. You can monitor the process per table, how many rows are still different, how many rows are on the source, how many rows are on the target. Yep. That happens with some queries. I extracted a sample here. And when you feel comfortable that your source and target database are equal, you can do something to analyze the source, to analyze the target if you're on old environment, and then think about switching to it. But when we think, we go back to the design and we want to see what happens. Currently, our load is still here on the source. PG Bouncer directs its connection string to it. The target is synchronized. Any change here is also synchronized on the fly. At this second, I decide, okay, I want to go here. I want to switch. And what I do here to achieve it is reschedule my application with new configuration for the PG Bouncer, or if it's hosted externally for the application, I just restage the PG Bouncer itself, changing the configuration to the target database. And that's an outage. I don't like it. It's maybe 2 minutes, but it still can result in customer loss. This is why I kept one more component in my design graph, and this is the Redis instance. How it works, Redis instance can be dealing only with read requests, cached data, can be dealing with sessions data to keep the sessions data in Redis for 30 seconds before going to the database itself. And this means we can survive for 30 seconds without connection to the database, because your Redis cache will serve and will never report to the application that it's down. This session doesn't disconnect. And how Redis achieve this? We said The Java application is configured to connect to the Postgres 13 node instance, and the active session data is hosted on Redis cache. And in periods of time written, maybe some data is written to the Postgres more often, but you can configure this, how often that can happen. Yeah, the connection for Spring Boot application, this is just example, don't focus on it. I just needed to put something on the screen, otherwise it could be one line of words. But this is just example how you configure your Java application with Redis and host cached session data. And of course, the last line is our simplicity. In our platform, we do this with one command. We actually bind the application to the Redis instance very easy with one line of code. Okay, during the PG loader, the applications are still connected, as we said. The PG loader continuously syncs the data and Redis holds the sessions. There is no downtime here. This is fully online for the customers and not yet switched over. We are still on the old instance. But what happens to the switchover? The application goes read-only for a few seconds. Why this is needed? Because we need to make sure for these few seconds our target and source and target are fully synchronized. We cannot achieve data consistency without being completely sure about this. So every single row should be on the target. Once we are ready, we update the PG browser target connection, and that can be achievable if you host it on like as external instance. This is achievable by CF command in our environment, so you can directly restage for a few seconds to the new host. And this happens with CF restage command. Okay, at this point, usually your application could restart, maybe, meaning this is the PG the PG bouncer application. So you lost the connections if you don't have the cache, but Redis keeps that data and keeps the data for the user sessions and never return back to the application, to the Java app, that this session has already died. It's died, but it's cached in the instance. So the application never recognizes this. It may not serve data. It may think a lot. It may wait, but it will never crash, and you will never see 404 here. Once everything's back up, your application just connects again to the database through that cached session, and this meaning is continuing the work it's doing. Okay, this was our cutover scenario, and I'll go back to the design graph. At the moment, we are already on the target. This is like a storytelling, not like deep dive, but I adapted to the stream today. So we are now in the target database, and our application still have the Redis cache active. It hosts some data for the sessions. PG bouncers control the load and transfer it to the target database. We are now on the new version already. And at this point, someone can say, okay, it's not working for me, it's too slow. I want to be back to 13. It's still live, but I don't like it. I want to be back if you are on a cloud environment without proper design on top, you will be also having big problems to rolling back this scenario. You will be doing restores, data movements, new deployments, some special techniques that do not guarantee any online solution. This is why we wanted to have the rollback scenario, and I'll really shortly go through it. If you want to achieve rollback, the only thing that matters is you turn this target to a source. So your new 17 version starts to act as source database. You put your 13 version back in sync, and you go through the same process once again, and you have rolled back your upgrade to the older release. And this is it, really short. It's not a deep dive, but it's a sample that you can achieve a lot more if you think about it. If you just think to utilize your cloud infrastructure in the way it is, it will be working perfectly. You will have upgraded instance, but you can have 20 minutes, 1 hour, 2 hours, sometimes really more than these outages. And these outages, the problem with them is it's not controllable by us, because we do not have control on the infrastructure behind our environments in cloud. And this is why on-prem is still alive. I personally, I'm not speaking like presenting any company here, but I personally still like to work on on-prem environments just because of the control, also the security and etc. This is why you know very well the new trending cloud model is actually customer-known clouds. And most of the companies will go there really soon. And thank you very much. I will save you some time, and for myself as well, because I feel a bit tired with all this conference organization stuff, but I hope you enjoyed that session. Yeah, thank you. Сега не можахме да викнем манекенки, ще ви посъветвам да се разходите по щандовете, но може и без манекенки да видите колегите какво представят. Имате 30 минути преди обяда и се връщате.
John Wong and Danish Han. He have an interesting name, Danish Han, like Hannes Paruch and so on.
Okay.
But it's a family name, I guess. He's some sort of ruler in India or something. I don't know.
Yeah, the Mughal emperors.
Yeah. So without losing more time, because the time is short, yeah, a big applause for the deep dive.
Hello, everyone. Good afternoon, and nice to see you all for this Data Stack conference. And we are here to understand, get a hands-on on like live demo and understand a bit about Cloud Native PG and running Postgres on Kubernetes using our operator, which is Cloud Native PG. So I am Danish, and you can see through like certified CK, CKAD, and a DOK ambassador also. So what is a DOK? DOK is basically an organization which is very vocal about running your workloads on Kubernetes, which is called Data on Kubernetes. And you can connect with me using this scanner on LinkedIn. And yes, I am with ADB, which is a PostgreSQL company, and for more than 5 years. So I am a contributor to Cloud Native PG as well. And over to John.
Hello. We're good? Hello, I'm John. As you can see, I don't have as many certifications as Danish does, so I just put my LinkedIn thing there to fill the space. But yes, like Danish, I am a CMPG contributor. I've been working on CMPG, which is the Postgres Kubernetes operator, for 4 years. I have 8 years of experience with Kubernetes. 4 in a previous role as like a system administrator running production OpenShift clusters, and then 4 at EDB working on CMPG and our related internal operators. Yeah, and you can connect with me on LinkedIn as well.
Yes. So yeah, go ahead.
So the way we're going to structure the talk is I'm going to do an introduction and sort of talk about the stack that we're going to use. And then Danish is going to do a demo, a hands-on live demo after that. So I'm gonna cover the stack. Our stack is entirely open source. It consists of Postgres, Kubernetes, and then Cloud Native PG, which is the Kubernetes operator that combines those. Danish is then going to demo this by deploying Cloud Native PG, deploying a highly available Postgres cluster. He's going to configure tests. He's going to implement a backup strategy. He's going to perform a live recovery, which is exciting, and then associated day 2 operations. So, okay, first, Postgres. So, does anybody here not know what Postgres is? Okay. Next slide it up. So, okay, what is Postgres? Postgres is a database. EDB is the company that contains the largest number of contributors to Postgres. So EDB is sort of, in a lot of ways, like the Postgres company. They always tell us in our all-hands slides that Postgres is the most preferred database by developers, according to the Stack Overflow survey. So it's a great database. It has, I'm not going to read all these. I mean, this could be an entire talk. Like, what is PostgreSQL? This could be an entire year of study probably. But so for our purposes, PostgreSQL is the developer preferred database, completely open source, and yeah. Okay, so what is Kubernetes? So Kubernetes, you're probably less familiar with than you are with Postgres. So who here, as a show of hands, who here knows what Kubernetes is? Okay, so most of you. Okay, good. That's probably why you're at this talk. So the way that I like to think of it, I feel like there are a lot of ways that you could answer like the what is Kubernetes question. I like to think of it as an API for orchestrating container runtimes by automating things such as failover, service discovery, etc. So when people ask me what I do, and I say I work with Kubernetes, and then they say, what's Kubernetes? I say it's an API. If they don't know what it is, I'm like, it's an API. So this pretty much says that it's open source, of course, just like everything, owned by the CNCF and written in Go. So why would you use Kubernetes? You can run applications, you can run Postgres directly in Docker. Like you can just run it as a container with no orchestration, but that is, and that's fine for like doing experimental things or doing small like one-off applications. But eventually you will need some of the robustness that Kubernetes provides. You'll need the service discovery to connect your applications to one another. You'll need the self-healing. Like if you have a Kubernetes node go down, you'll need to use a Kubernetes primitive like a deployment or something to recreate your application when it fails. So why Kubernetes? For flexibility, self-healing, and security resource management. So this is a pretty simplified, but I mean accurate diagram of how like a Kubernetes, like a small Kubernetes cluster of like 3 nodes would look. You'll have the control plane that does all of the orchestrating, and then typically would be a node, and then you would have 2 worker nodes where you schedule pods onto. All of that. I mean, we could get in again. This could be a huge slide, but just for the purposes of this, when you're deploying an application on Kubernetes, typically you deploy a pod, and the pod contains the container that runs the application. Occasionally, you'll have 2 containers in a pod. If those share the same life cycle, like the container represents an application, and if those applications share the same life cycle, they might be in the same pod if they're very tightly coupled, or they might communicate using the Kubernetes network and be in separate pods, just depending on their coupling. Kubernetes gets compared to, well, containers gets compared to VMs a lot. I think VMs are something that everyone is sort of intuitively familiar with because a VM sort of is just a virtualization of hardware. And I like to think of the differentiator between VMs and containers as VMs virtualize hardware, and containers, they virtualize the operating system. So containers are always going to be more lightweight, and VMs are always going to have more like stricter isolation, because a VM, you're going to have your own kernel, and a container you won't. So the idea behind that we had for running Postgres on Kubernetes was to make the experience be as Kubernetes and as cloud native as possible. And that's seen in the name of the operator, in that it's cloud native PG. It's not like trying to bring any traditional like DBA bare metal concepts to Kubernetes. It's trying to, the idea was to like have a way to run Postgres that is completely native to Kubernetes. And so in doing this, there are fundamental concepts that I think for a more traditional DBA would be different, or perhaps new. And so these are sort of the Kubernetes primitives, or the Kubernetes, I guess you could say, like core things that a DBA would need to know in order to work with our operator on Kubernetes. I'm not going to go through and read all these. Maybe I think they're good. So like I was saying, Kubernetes is an API. Is the way that I think of it. And I would say that a Kubernetes operator is a way to extend that API. So like Kubernetes would provide by default a primitive like a pod to schedule applications. And then with an operator, you could add additional API endpoints to your Kubernetes cluster to then deploy new resources. Operator to deploy new resources such as like a Postgres cluster or Postgres backup, etc. So the way that an operator works is it has so it does a reconcile loop. It's like an event-driven reconcile loop in Kubernetes. And so what you're constantly trying to do is you define your state within the API, and then the operator will take that state and will try to declaratively get your application to the desired state through a state and a status setup. So it would have you define your state in the spec, and then you have the operator will read that spec, try to make things be in that way, and then if they are, we'll update the status. So it's very similar to a state machine, I think, just like everything. Yeah, sorry, I kind of skipped around. So yeah, this is a good slide. So this is exactly what I was just talking about. So you would so like if the cloud native Postgres operator adds to the Kubernetes API, adds a cluster like a cluster definition. So now the Kubernetes API has an extension that it understands what a cluster definition is. Then you could create a cluster in YAML, which we'll show in the coming slides. You could define a cluster in YAML. The Kubernetes operator will read the YAML, see the desired state, so perhaps 3 Postgres instances, and then the operator will do whatever is needed to make the 3 instances come online and be healthy and connected and running and like receiving connections, everything that you need for Postgres. And it would know like where it's at in that process through the status. I'm waiting on maybe a new microphone. Talking about Postgres, talking about Kubernetes, talking about operators in a general sense. Cloud Native PG is the operator that it's fully open source, and it is the operator that we're going to be demoing today to show how to create and run Postgres. So yes, and this is pretty much what I was just saying. It's an open source operator. It was originally developed by the company we work for, Enterprise DB, which was really good. The approach was because Enterprise DB has always been, like I was saying, the Postgres company. That has always been like the core product is selling like services or selling like support on Postgres, and so Enterprise DB has a deep institutionalized, like very firm knowledge of Postgres and ability with Postgres and skills with Postgres. And so I feel like they were a great place to start Cloud Native PG because they were able to bake that into like how we built the operator to be cloud native, but also maintain all of the like deep institutionalized knowledge that we had from running Postgres as a support company for years. So Cloud Native PG was started by Enterprise DB. It has since been donated to the CNCF. It's fully open source. It was started by a separate company called Second Quadrant that was acquired by EDB. When I joined the company, it was closed source still, and we were on the path to open sourcing. I don't know if any of you have ever open sourced an application at your company, but there's more steps to it than you think. It's not like exposing a GitHub repo. There's a lot to it. But after a lot of work, we did get it done. We open sourced it, and then we did donate it to the CNCF the CNCF has levels for projects, like based on like the community and the popularity and the like centralness of the service. We're currently a sandboxed CNCF CNCF project, and hoping to grow that into an incubated status. But yes, so I mean, vendor neutral. It was started by EDB. The maintainers are the majority of the maintainers do work at EDB, but Cloud Native PG is owned by the CNCF. It's the CNCF's project. I think it has, yeah. Very good. I think we just crossed 7,000 stars on GitHub. So I think it was 7,000. So Cloud Native PG is more than just specifically an operator. The operator is the main part of like what is provided, but Cloud Native PG is sort of becoming an ecosystem. Very recently, there has been added the support to add plugins into the operator, which I think can be thought of sort of as like extensions within Postgres. So additionally, within the like Cloud Native PG ecosystem, there's the Cloud Native PG operator itself, and then there is a plugin to support barman backups, so like backing up your data onto S3 storage, which I think is going to be in the demo, right? Yeah, so we'll be seeing that soon. When you talk about operators, typically they are thought of as like being like at a level in terms of automation, really, I think, or just how much of the life cycle of the thing they operate on that they can control. It's a level 1 to 5. This is sort of, I don't know where the standard comes from. I see it a lot on like the enterprise Kubernetes deploys, like for OpenShift, they have this grade of like 1 to 5 for the operator. And Cloud Native PG is level 5 in that it automates, as you can see here, it automates a very large part. Once you configure in YAML, it automates a very large part of what you would be doing if you were a DBA. In terms of like running backups, like you can do scheduled backups as like a primitive. You can do, it does failover automatically. It's highly available. Yeah.
So this is coming from operator framework.
Yes, exactly. This is, I think, operator framework is who came up with that. Yep. So we are level 5 on the like Red Hat certified catalog. So this is a very basic example of, well, so going back to when I was talking about Kubernetes as an API, an operator extends the API. This would be an example of the one of the primitives that the Cloud Native PG operator adds to the Kubernetes API. So this is it adds the idea of a cluster, like Kubernetes by default would have like pods, deployments, replica sets, stateful sets, etc. The CNPG operator adds the idea of a cluster, and this is a cluster of Postgres instances. And you can see a very simplified version of a spec. This will work. Like this spec would be valid if you installed it. Typically, in like in a production setup, you would have probably a bit more configuration than this. Yeah, this would be so you would create this. It would be a Postgres cluster. It would have 3 pods. The pods will be managed by the operator itself, not by some other Kubernetes primitive like a deployment or a stateful set. The operator will manage the pod scheduling. You'll have a Postgres image, so this one will have this. We also added to this example a node affinity. So like in a Kubernetes cluster, you might only have certain nodes that you want your Postgres workloads running on. This would, if you had those nodes labeled for Postgres, this is what that would do. And then 2 different storages, one for like your PG data and one for your wall. And okay, so yes, thank you to the maintainers. There are, I don't know how many maintainers, maybe 8 maintainers, maybe 7. most of whom, like I said, are at EDB, but there's a few at different places. If you want to contribute, it's an open source project, and that means we're always looking for more people to contribute to it. So if you have interest in contributing, I think it's a very welcoming community. I hope so. Always eager to help people learn. Very active on the Kubernetes Slack, I think. Very active in, yeah, I think it's just there now because we had our own Slack, but we got rid of it. So yes, and of course, thank you to EDB for the donation of the intellectual property. It's hard for a company to donate something that they spent a ton of money on developing and giving it to the community, but it's a great thing to do. If you're, I don't know if you can reach, but if you want to scan the QR code to go to the GitHub, please do and give us a star. We do track how many stars we have. So if everybody here starred it, that would be, I don't know, maybe like 50 stars. That would be great.
And also maybe contribute to the testing when we build the some snapshots.
Absolutely. Okay, so that is it for me. I'm going to turn it over to Danish, and he is going to be doing a live demo. So give it up for. Oh, actually, does anybody have any questions before we go into the demo? Like anything about what we're going to show or none? Okay,
Yeah.
perfect. What kind of storage is supported is the question. So that's a very good question. We do support any storage that your Kubernetes itself can provision. So the way that we do storage is we will provision the Kubernetes native PVC, and then it will be up to how you've configured your Kubernetes cluster and your CSI drivers to provision whatever storage you have in your backend. So typically some type of block storage.
Yeah. And it is, yeah, absolutely. And it supports all the cloud storages we have tested, and also Longhorn.
Yeah. So it's important. Yeah. The operator's interaction with storage stops at Kubernetes. So the operator will create a PVC, and then will sit and reconcile until that PVC is healthy. So then, as long as your Kubernetes cluster can create PVCs, then the storage will. You're saying, I mean, that would still be dependent on that would be like a Kubernetes cluster configuration thing. Like you're saying, like if you have local storage, like local to a node. Mm-hmm. Mm-hmm. Yes, I see what you're saying.
So I understand you are asking moving your clusters from one place to another using the storage, right?
That's why you configure Affinity.
Yeah.
The Affinity, I think you can configure all the pods to be zone aware, and the scheduler will know to schedule the pod in the correct AZ.
I'll explain that part. How do you configure things for production? Probably. Yeah. Yeah. Thanks, John. Thanks for explaining and warming up the session. Yeah. So let's go to the action. So probably I am going to use. We have created a CNPG playground so that it is very, very easy for the community to actually go and test the features. So you can scan and go to the GitHub and bookmark it for future use if you want to try it. So yeah, if you scan, and then I'll give 15 seconds and I'll go back to previous section. Okay, so how many of you run Postgres on Kubernetes? Nice. And how many of you run Postgres as a workload? And how many of you use Kubernetes? Perfect. Okay, so let's understand this part, and then I'll go to the demo. So John already explained. I wanted to explain about the affinity part and how do you configure things in the production. Like, yeah. So you always uh, do the pre-warming when you deploy the databases, like, right? Like, I come from a background where I used to run the Oracle rack. You know how many days it would take? Like 2 days to prepare this whole setup, the real active cluster from Oracle. If so, going through this session, you'll understand how good the operator is deploying those. Now, when you select the nodes, you select based on your transaction and the workload, right? And then you try to put labels on it. You all know about labels on the Kubernetes, right? So let's say node is equal to Postgres, and then you put the same thing in the configuration. Like John explained, it's an extended API. So whatever Kubernetes support, we have integrated that with our operator. So like CRDs, it will go and check for those nodes which has the label as Postgres. If you define it, if you do not define it, it will go elsewhere. So try to define your node affinity, anti-affinity, whatever you want to, everything is supported. And then the pods will go to that place. Okay? Okay. So this is the requirement. So I'm running this on my laptop using a Kind. Kind is again a short version of running, like light version of running the Kubernetes on the laptop if you have a good setup. And of course K3S and Rancher has one, so like everyone has their own setup. So yeah, I'm using Kind for this demo. So like I have used these many things and these are the requirements. You can take a snap of it so that if you use CNPG Playground, so you can have this as a prerequisite. Also these are all things in the README of the Playground. Okay. Okay, so cloud native PG installation. Perfect. So I'm just trying to go in the namespace where it will be deployed. Perfect. This is the namespace where we deploy the, okay, so namespace, pod, these are Kubernetes terminology. So I'm assuming you guys will follow what I'm explaining, right? Based on the Kubernetes experience you have. So yeah, so if you take a look, this is a operator. And it is deployed using this one. So we have the latest release, which is 1.27.1. Right? So like if you go to the, like here, the cloud native PG page and just go to documentation and just explaining how you can navigate through the, yeah, and then you installation and upgrade. So this is what I'm using there. So you just copy this and kubectl apply and the operator will be up. Based on your network, and it will pull the image, of course. Okay. Perfect. So make sure your operator is up and healthy. And like we have given commands to make sure that, right? So you follow the documentation well. So it will ensure that your operator is, because operator is the thing which will manage all those. Like he explained, desired state and the actual state. Operator will always try to put the cluster into a desired state. That's what we want it for, right? And it is easing a lot of problems what DBA would be facing, right? Like self-healing is one of them. So to 12 a.m. in the night, you would not want your cluster to go down, right? You want the primary to switch over and then the cluster to be healthy. Okay, and we have CNPG plugin also, iPlugin, which we will use for backup and other stuffs. And we have a tool which is CNPG plugin. We will use it for like demoing how we promote the primary. Okay, so perfect. Let's deploy a simple cluster, like very basic cluster. So this is a very, very, very basic cluster example where if you see there is a name, and this is of course our CRD, right? And this is kind which we have created using the operator. And yeah, this is mainly meant for the backup section. So like cluster example would be already existing, so we can rename it for, like we can say cluster example number 2. Okay, and font size, okay, yeah, sorry, perfect. Okay, I'm using min.io as a S3 object store to like ship my wall files and backups. Okay, so let's apply the cluster YAML. Okay, let's okay, now we apply in this namespace. So it is created. Let's quickly take a look at the so it has not yet started yet. Probably will wait, and we can take a look on what we have in the while it creates. Okay, so yeah, the same cluster is created here. If you see, oh, let me go into the default namespace. Yeah, perfect. Yeah, so if you see, this is the cluster example 1. So understand, so what is cluster? So like we have deployed a Postgres cluster with 3 instances, the primary and 2 standbys, and we will understand what resources they have. Okay, and if you see like what is there in the definition of the cluster, and you can run all the commands what Kubernetes might have. So if you see, like I said, so it will have 3 PVCs, which is healthy, 1, 3, 4. Of course, 3, 4 I was doing some like experiment over there, so you will get it increase. So it was 1, 2, 3, but I deleted number 2, so it was 3 and 4. Okay, and the instances like this. Now the operator will always, even if you delete one, it will always try to bring back it to like the desired state, which is 3. Okay, and if you see, we did not. So if you take a look at this example, we did not define any Postgres SQL parameters, right? We did not define any of the Postgres SQL parameters, but if you see here, you will find some of them, right? So we have defined these are the basic things which we need to like run the Postgres SQL. We put it. If you define yours, there is a section. You go to the Cloud Native PG page, and you can define. I'll explain in one of the slide where you can change the configuration, and so you cannot change all the configuration, but you can change some, right? Whatever is possible. Yeah. So you see this, and then yeah, we are using like Barman for our backup and restores. And what we did, so earlier before 1.26, the Barman was integrated in the Cloud Native PG. Now we have went away from having that inside the Cloud Native PG to use it as a plugin. Like we have developed Cloud Native PG plugin as well, where you can run the Barman using that plugin to take your backups and restores. And you, for that matter, you can plugin is in such a way that you can like bring your own like tools and you can integrate with Cloud Native PG. Okay, and now, okay, let's take a look at what all things were like created. So one thing was cluster. Let's say get PO. Yeah, see cluster example number 134 running. Even you can run what all labels are there, on which node it is running, right? And you can do show labels, what labels were put like this, right? So like typically a Kubernetes admin would do something like this to understand the pods, and if you want to configure some monitoring, you would go and do something like this. Let's take a look at the services. So if you see, these 3 services are getting created, right? So let's, you guys are able to see the screen? Should I increase the font? That's okay. Let's take a look at how it would look here. Okay. So look at these 3 services, R, RW, RO, and RW. Okay. And let's go here. This is what we deployed actually, right? Typically it will be a primary on worker node number 1, then the replicas on different node, and they will be in sync with the primary always. And we promote the most sync replica to be the primary. Okay. So if you see read write service, this is pretty much tied to the primary, if you see, because the write will always happen to the primary, and of course if you are connected you can always read, right? Read only service goes to the replicas like that. So we have segregated those things, right? So you do reads on the replicas and you do writes on the the primary. So if you want to configure your application, you can consume these 3 services to configure your application, maybe via load balancer, whatever, however want. Yeah, like you have the leverage, you can do selectors and like integrate these services, and you can take a look at this further. So let's say get service and take a look at this read write, and let's take a look what pod this have. So this has the cluster IP as 10.96.24.162, right? And what pod it has? It has picked up the primary, like I said, right? Like in the example over here. Sorry, yeah. And then if you go here, you can see the IPs over there. So that's how you validate that you are doing the right thing, having your read-write services attached to your primary. So when you create the first instance, you always validate these things. Okay. So let's find out what 24162, the cluster IP. Yeah. Okay, another thing. Let's take a wider look. Okay. Sorry. CNPG is a tool which we have developed to take a deeper look inside the cluster. So if you run this, you will be able to find everything over here. So like you can also do kube, like we did kubectl, get cluster and then cluster name and then -o YAML. And we go further with the CNPG tool. We try to define what all, where it is, the walls and all, if anything is problematic in that. So if you see status cluster in healthy state, right? So we try to pick what type of image it is using. So this is using the latest version of the Postgres SQL. Okay. So if you see wall is archiving. Okay. Yeah. Let's take a look where it is archiving. So we have min.io, like I said. Let's take a look at the min.io. This is our min.io. This is our cluster. So if you see, we'll see a lot of walls getting shipped over there, right? And this is what it is saying, yeah. So, and we have backups also. We will go through the session, like we will see everything. Perfect. So far, any question? So service was one thing, pod we saw, and then we will try to look at PVCs. Okay. See these three PVCs which are attached to like our cluster number 1, pod number 1, 2, 3. So if you want to get rid of the instance, you have to clean up the PVC also. Just not deleting the instance like the pod will not help you. It will create problems. So when you are cleaning up your resources, clean the service, clean the pod, clean the PVC. That's it. And yeah, so if you see storage class as a standard, so like let's take a look at the what storage class kind gives by default. Standard, which comes from Rancher, but you can deploy a Longhorn. The problem with the other deployments is that they do not have a better integration like kind on Macs, or probably emulation. It doesn't work very well. So you have to look for other virtualization things to actually deploy Longhorn and all, right? So kind doesn't good that with Longhorns, but you can deploy Longhorn and use Cloud Native PG to create a PostgreSQL cluster. And if you want to take at what custom resources which we have created, like John explained, we are following operator pattern. So it will come to mind, right? Yeah. Why operator? Database, they are stateful, right? You need a consistency. So Kubernetes stateful state was not helping the database community. So we chose to be like operator person, right? We chose operator pattern. This way we had leverage to define lot of stuffs. Even we can expand our volumes. So if you're like I said, if you see here, so allow volume expansion, this is false, but you can increase the size as a offline increase in our cluster. So if you want, so there will be a downtime, of course, if you increase the sizes of those, like the replica will be created, like restarted, then the second one, then the first one, like that, right? The hot one is a different story. So cloud providers support hot volume expansion, so it will do automatically. Don't worry about it. Okay, but we try to keep the minimal impact. So we try to increase the replica first and then the primary. So when primary happens, so if it is required, we do a switch over. If it is not required, it will just sit like this. So your actual read-write operation will continue if you have defined it in your application from the primary. Okay, so always when you are deploying, so like the way I would deploy in production, I'll look for the storage class which supports volume expansion. GP3 has one problem. They allow only one expansion per 3 hour, I think, AWS, right? So you have to be careful when you are expanding those things. You do not like always make a like conscious decision and when to like increase those, right? So always be ahead. Do not increase something. Let's say you have exhausted 98%, and now it will not allow you further if you like you increase 10 GB and 98% was already filled. Let's say you have some problem with the wall files. It will fill up 10 GB again. And then you are stuck because GPT will not allow you, right? GP3 will not allow you to expand it further. So you have to be careful in like storage classes. So understand what you want to use and what features they provide, and then use those in our cluster definition, right? Perfect. So let's see how far we got. So I am following this, but I am following like playing around it. So this we did, this we created a cluster. Okay, we understood this. Yeah. So service PVC cluster we all see. Okay, role binding and SA. This all will be there. So let's say like typical stuffs, what would the Kubernetes provide? These are the roles. If you see role bindings, these all are required. So yeah. Sorry, I'm not able to hear you. Yeah, so we are, yeah. I mean, like, actually, can you ask it again? Okay, we are not managing storage as such. So stateful set also we are operator. Operator pattern is different, and stateful set these are not stateful set. These are deployments. If you see. Yeah, yeah, please.
Oh, okay, I am back. I'll repeat the question, so make sure I understand it. Correct me if I don't understand it. But the question was, does the CMPG operator, is the underlying Kubernetes primitive that it manages, is it a stateful set or is it a pod? And that's an extremely good question, because so if you're not familiar with what a stateful set is in Kubernetes, it is a way to describe some number of pods that you want to start in a specific order, and it's meant for stateful workloads. So it would seem like that would be a good way to manage Postgres, would be with a stateful set, because Postgres is stateful. But no, we have a controller, we have a cluster controller that fully manages on its own directly pods and not stateful sets.
Okay.
And the reason we do that is because there are certain Postgres like operations that might require pods to come up in different orders, and so the resource that is defining the Postgres cluster needs to also understand Postgres. So it can't be a stateful set that's always going to do like 1, 2, 3, 4. It needs to be more Postgres aware, and we have that baked into the controller.
Yeah. Thanks, John. So yeah, I mean, like it's always the question like why we moved out of that, and yeah, it's like, but it's beautiful. So we have a leverage, a DBA. What do you think? Like it's making the life easy, the operator. So you have your control. Yeah. So like SA again, these are the clusters. So cluster example is one first cluster, and there are others. Okay, let's see. Yeah, pretty much we saw everything here. Okay, now you want to see, like, look into your databases, right? What is there? So let's run. So let's first figure out what is my primary. So we try to give as much information as which is useful. So if you see, first one is name, age, instances, and how many are ready, and then the status and the primary. This is very useful in getting a quick view of your cluster. So here, if you see cluster primary one, so let's connect to that. So typically, how do you connect on a Kubernetes? Like exec on it, right? So and just PSQL, right? And then you can do /du, right? So this is all app is one database, right? You can look through it, and then you can see the this is more beautiful than the other one. So this is how you run your Postgres queries over there. Like if you want to quickly take a look at glance, but we have connection strings, which is typically being used with those services. You can connect to the like these instances. So far we understood the cluster concept and the resources which we are creating, right? So are you guys following me? Or perfect? Yeah, of course. So secrets and all, like this is required. Like we have MTLS. All the pod communicate via certificates and MTLS. So we typically rotate those certificates, right? So you can get those information from, again, you can, let me get out of it. So these many secrets will be created when you create a typical cluster. Like when I says these many, you have to follow the cluster example one. So which will give you the idea, right? So app is used to connect to the app thing, right? And then CA, then the replication, right? So everything is created uniquely for its purpose, right? We do not want to mix things, if you see. So you can read about it. I'll leave this slide with the data stack page, and you can always reach out to us on the Slack or on the LinkedIn. We will help. So I mean, like, you can look through what is there, but it's fine. You can take a look. See, so you can take a deeper look on the secrets, how it is created, and probably the expiry date. Yeah, see, this is typical Kubernetes. That's what we are using, right? So the life cycle of this pod. So you will want to understand what is happening in the cluster, right? You will always want to look for the logs. Then you will always want to look what type of version I am running, right? These kind of things as an admin you want to understand, right? So let's take a look. Like typically with like 1,000 of instances running, you would like to know what is the host name of that company which is running the Postgres instance, right? These are the things, right? So let's run some of the examples. So let's take a look at the log. So of course the primary one will have all the latest logs because all the write is happening over there. So yeah, see, and even if you remove JQ, so JQ is just to like let you visualizes, and then you have the log managers which will rely on those JSONs so that you can like attach them, right? So yeah, probably somewhere. So checkpoint, I did run checkpoint to ship the walls, right? So it will log everything. Probably it might have also walls, and I am finding if I have ran any query. Probably not. Just fine. Yeah. So this is how you take a look at the logs of the pods. So this is very, very useful. Again, if you see, it is very tightly coupled with the Kubernetes ecosystem. This is Kubernetes log, the command. There is a typo though. Let me fix that. Yeah, so you can use them directly. And then, yeah. So if you see, this is kubectl CNPG. CNPG is our tool which allows you a lot of operations, and we will go through those as we go in the session. So let's connect to this instance. So I did connected using the kubectl exec, right? Exec, then IT, and then I did PSQL. Similarly, if you just run, I will always advocate about CNPG tool. You use it very extensively if you are a cloud native PG user. It helps a lot. Even you can collect the logs with this, very detailed logs, right? You can go through the documentation. So see, in one command, you don't have to look for anything. You know the cluster, and you're just there, right? And let's run this. Yeah, so did I did any typo? Should be fine. Yeah, cluster example one. This is our host name. So these are some basic examples. So typically the Postgres guys would like to love experimenting it more, like do something with it. Perfect. I mean, yeah, of course we want to test the controller. So let's take a look at what happens if we delete a pod, what will happen, like automatic failover, and we'll see promoting a replica. So these are typical operations of the operator to maintain the desired state. So you delete a pod, then operator has to understand that something is deleted. So you created a 3 instance cluster, but now it is 2. So operator will try to bring this up to a like instance 3s, right? And always look for the nodes which is available to schedule it, right? All those things happens in the behind, right? So it's typical Kubernetes. It will ask Kubernetes, give me a node. It will give you a node based on what definitions we have. Then the pod will be scheduled again. So let's find out the primary, okay? So cluster example 1, okay. And then let's take a look at cluster. Okay, so this is now in healthy state, and we will see the state changes. Again, a Kubernetes command. Sorry, 1. Deleted. Perfect. See how quickly it is started a failover. So it was in healthy state, and now it is waiting for the instance number 3 to come. If we see here, sorry. So the pod is initializing. So like I explained, so it saw that the number of instances is not 3. If you see, it is 2. So it is creating that pod for us, right? And the beautiful thing is, it did a failover over here, if you see. So your write operation is never impacted. Actually, it did a failover within second. So your most synchronized replica is now the primary, and which is cluster example 3. So what was your primary? Pod number 1. What is the primary now when we deleted? It is pod number 3, right? Which was the most synchronized replica. So this is the beauty of this operator. You, in the night, the primary got killed by something, OM killed anything. Yeah, and this pod is up and running, right? This is what we want in life, right? Like, do not wake up in night and the cluster is healthy. Perfect. So let's try to promote. So if you see all the commands we support here, it is available. If you do like kubectl cnpg, you can go through all the commands. Okay. Now I'll take a pause and let you understand how to like be ready for the production deployments. We have integrated FIO benchmarking. FIO is basically a tool to benchmark the storage. We have integrated that with the cloud native PG operator with the tool actually. With the tool you can run the FIO benchmarks if you want to like know what type of storage you want. So when I say storage, so we typically in the Postgres it is PG data and the wall, right? If you have more transactional data, you always look for good storage in the wall, right? And how do you know it's good or not? So you always run FIO. Then you have some benchmarks, right? And then at the end, when your cluster is up and ready for handover, you run another tool which is pgbench, which is again like default tool for load testing in the Postgres community. So Postgres guys will always know about pgbench. Then you compare pgbench datas with the FIO. If that matches, it doesn't need any tuning. If that doesn't matches, you need to tune it further, like what type you want to use, right? So another thing, so after you have done this, then you identify your nodes, like what large node you want, high CPU, high memory, like that. Now another concept in Kubernetes is your resource utilization, which is your CPU and memory. So there is a limit which is defined. So you always define limit and resources as same. That guarantees that your pod will not be killed. So what happens in Kubernetes world? So Kubernetes kills them which do not have same, like if you see these things. Let's take a let's take a look the resources here. So we have not defined any resources here. So this pod is likely to be killed by Kubernetes first. But like if you see, go here. So we have go to the resource management. So if you see resources, request and the limits, both has to be same to guarantee that the Kubernetes will not kill this first. So Kubernetes is a shared environment, right? A lot of other pods will run, right? So they should not clash with each other. So you identify your node, you put taints on those nodes so that no other pod should go on that nodes, and then you put toleration on your cluster definition, like the pod should go on those nodes only, and then you define the CPU and memories so that you get a guaranteed QS while running those workloads. This is the way for production. So what you do, run the FIO, configure the guaranteed QS, like resources versus limit, both should be same, and then you run the PG bench, and then you should be happy. Okay? Then comes your scaling. So what will happen if the load increases? You always want to scale, right? Right or not? So we support scaling, like Kubernetes. If you run Kubernetes, scale replicas to like anything you want to. So let's see how many replicas we have. So 3 are running, 1, 3, and 4. And then let's see. So if you see cluster is a resource, so like if you see kget PO, PO is a Kubernetes resource. So we have defined cluster as a resource over here. So if you do kget cluster, you will get, so if you see instances 3 and ready 3. So let's run the scaling. Again, K scale cluster, K is, okay, so K basically I created an alias to kubectl, right? To like quickly run the, it is kubectl, K just don't get confused with K. It is just an alias. So let's say I want to do 4. I see. Okay, we have to define the cluster. Perfect, it says a scale. So let's see if it is coming up. So it is coming up, you see. So it was 3, then we say number of replicas as 4. So it is quickly coming up. And if you see the status of the waiting for instances, and then it is healthy. So the healthy state will always change, but that doesn't mean your write operation is not happening. Healthy state changes, you have to look for further investigation why it is not healthy. So in our case, we already knew that we have scaled. Now the beauty of this scaling is now the number of replicas or the desired number of pods is 4, but it was 3. Number 4 was not there. So the operator sent a signal that, okay, you should be going back to like waiting for the healthy state, and the instances should be created, right? You are not healthy. Now when those are all up, like number 4 is up. So now the desired state and the number of count of the pods are same. It will go back to the healthy state, right? Which is what we want. And you can also scale down it. So let's say like you are done with the replica, so you can do like this. So yeah, again it will do the same thing. So let's see. Perfect. The number 5 is gone, which was created, right? So you scaled up and then you scaled down. So like we said, it is all coupled with the Kubernetes, right? And these all features which we have explored there to like integrated with our operator. So far, any question? Yeah.
Can you explain us more about day 2 operations, like, for example, handling regular analysis or configuring the auto vacuum? Is there something in CMPG that will help us to automate the auto vacuum and have better analysis from that? And second is that since the Postgre is extremely memory intensive, is there something that CMPG will help us to configure stuff like transparent huge pages or anything like that? Because normally those are the problems I've seen in the past, and also some of the considerations migrating from RDS to something managed in Kubernetes. Thank you.
So I don't remember exactly in the cluster spec where it is, but you can define like you can set like your PG-HBA conf. You can define that explicitly in the spec. I think but yes, that was kind of what I was alluding to as well when I was talking about how our cluster example is not necessarily representative of a what a typical production one would look like, because you'll probably have like your own Postgres parameters and stuff set to be like specifically tuned for whatever your workloads are. So yes, that is exposed somewhere in the spec. I think it's
you can explore, and probably some would be at the enterprise level, like transparent TD or something like that you are looking for, right? So probably you should get in touch with EDB. Like we have a lot of solutions which we expose it, but then like maybe out of scope for the current, but we can discuss it. We can take this up offline with you and discuss what problem we can solve for you. But it solves a lot of problems. So a lot of Postgres configuration, we expose it, even the, parameters. So whatever Postgres have, we expose it, whatever is configurable. So you can like shared buffer for that matter. It is configurable. So if you see right now, there is no shared buffer in this configuration, but I'll show you how to configure it. And you can also, so if you see let me show you, just allow me a moment. We have a lot of examples which you can go through. Probably if you go here and go to docs and go to source and go to samples. We tried to keep a lot of examples over here. So if you see example, this is what I meant. So you can, it is possible. So if you see, even if you see here, see, so we tried to cover the problems what DBAs might face. Like you took one example, which is a good question, right? So why not let's go take a look. So we have given those examples. So it is just not documentation. It is there, you can try. Yeah. So I hope you try and like, it's also out of box. Metrics is also there. So It will be at instance level, but I have to check. So every instance will be exposed to the Grafana. So there is a dashboard, and we have Prometheus also. So you can enable. So you have to enable a pod monitor. Then when that is enabled, it has a different configuration. So the basic one will. So you enable pod monitor because you need the monitoring, and then you look those instances on the Grafana using Prometheus and Grafana. That's also. So if you see this section, probably go to documentation. So see, so we try to cover everything. That's why we say it's level 5, right? So for production, monitoring is important. So you can play around. So we have given a default dashboard, but you can like have your own, right? Perfect. Hope we answered. And thanks for asking the question. So which, yeah, correct. That's how we help community, right? So we took a look, like deleting, checking the failover, yeah, scaling we took, and let me. Oh, probably we have time, so we can take a look. Okay. So yeah, failover we saw. Let's take a look at this slide. So, but we saw the live action actually. See, so this was gone. Primary one was gone. Then the read write was changed, right? It was given to, in our case, not to 2, it was given to worker node number 3, if you saw. But this is an illustration. But again, it was the most synced primary replica, so it went to the number 3. And then it comes up, then it becomes the replica, right? And everything is up. Okay. This was what we did with deleting that pod. Then again, we can do a yeah, let's take again, like I said, so take a look at this, right? So what is our primary, which is cluster number, like pod number 3, right? So what we saw was a failover. What we'll see as a promotion to a primary. And we'll also put a check over here for the cluster. What is happening with the cluster in the status, of course. Then we say, so kubectl cnpg, the command which you saw. Then the following command is promote what cluster you want to promote, because you will have many clusters, and the instance number you want to promote. So you have to take a look at, like sometimes you will face like primary is down, but it was not automatically failed over. Then you can always go and promote the replica. So let's say, so it was 3, let's promote number 2, or switch it back to 1 probably. Let's see what was the, see, that was okay. If you see, that was a failover, right? And what you got here is a switchover, because we manually promoted it. So we switched the primary, and now the cluster is healthy state, right? So we promoted instance number 1, and we have now see pod number 1. So these commands are very useful in like catastrophic situations. So you can quickly bring your cluster write operation back on track, and then you can investigate with the logs. So why it is created? To help the DBAs to like quickly recover the cluster and then analyze the logs further. Okay? And like Kubernetes will always keep the logs. Like you have a log collectors where you can always push your logs. We suggest to do that, otherwise it will be a problem, and then you'll have policy to rotate it also, right? Any questions? Perfect. So we tested controller, we saw feature of scaling and putting back, we saw failover and how quickly it was with a very low RTO, and then we saw switchover, right? Now the beautiful backup, right? So backup, like when we always advocate to have the wall archiving enabled. You always ship the walls to S3 object store so that you recover it well. So, and then you take backups. If you are not configured those, then we have another solution which is volume snapshot, which you can like quickly create. So Kubernetes supports volume snapshot. We also support volume snapshot, and then we have given plugin, CNPGI plugin, which supports Barman Cloud, and then you can integrate with lot of other tools also. So right now, volume snapshot, with that you can create a backup and restore a cluster, do a PITR, and then you can have Barman Cloud, which you can again do the backup. So we'll see an example with the Barman Cloud over here, right? Okay, perfect. So let's take a look at this cluster. Like I said, we went away from the typical integration of Barman Cloud inside the Cloud Native PG operands to like isolating it. So you'll not see anything. Then you have to deploy the plugin. So there is a document available here. If you see, you have to follow this document. So this will enable you to configure your backups using the Barman Cloud. So if you see here, like these are its requirement, of course, Cloud Native PG. That's how we integrated it. And then the plugin, and then you can use any of these. So we have used MinIO. If you see MinIO, so K get PO, you will see a MinIO pod running. So we had the earlier images. Now MinIO has moved out of giving the like community images. They have a licensing now. Perfect. So this all is configured, and then you go and take a look at the installation. So if you see these sections defined, like how you can configure the Barman plugin to take a backup and all. So these all are objects which is already created. Let's take a look. Get object store. So MinIO store which we created, which will use. So this has the definition of where your S3 bucket is. So -o YAML. So if you see, this is the destination. If you see, and MinIO local, which I created, which is running on, and then we have the credentials, which is access key and ID. So you can take a look at these credentials inside the MinIO pod. How? I'll also show you. So if you, it's running on a Docker actually. So if you see, we wanted to explain how we are connecting remotely. Of course, I can always run the MinIO inside the Kubernetes, right? It's always useful. But Docker, again, it's different than the Kubernetes. So from Kubernetes, we are sending that to a Docker, right? The MinIO object is running on the Docker. Perfect. So if you if you want to know the credentials, you can always look into this. And then you can, perfect. So this is from CNPG Playground. We created this script for playing around. So just echo and traditional stuff. So CNPG is the username, and then you can similarly get the password. That's how I logged in. And we have defined this in our setup, so that's why. So default one is min.io admin, min.io admin, and this is how we have defined it. So again, echo, and so it will give you the password, right? Perfect. So the backup, so okay, let's get backup. This is our backup. So all of the, so if you see this, this is all defined as the CRD, custom resources, right? So I took 3 backups. Let's take another backup. Why not? I'm trying to quickly grab a, yeah, this is the command. Okay, so if you take a look at this command, again, I'm using the CNPG tool, then the backup, then the cluster name, and method is plugin. Like I said, we are using the Barman Cloud plugin, and then the plugin name which we are using. So you can have your own plugin, and then you use this command to take the backup. So if you see, backup is created, then go take a look here. Completed 7 seconds before. Of course, we do not had that much of data, so the backup was very fast. If you have data, it will take some time, but that's backup. So always take a base backup, then your wall archiving should be up so that you can restore the cluster. Right, so let's restore a cluster. Take an example. So we have this YAML, right? So let's understand this one. So yeah, perfect. Let's, for that matter, let's say data stack. Okay, image pull policy if not present. The image which we are trying to pull, you always, like, if not present, pull. If there is image, always use, right? And then this is the plugin name which we are using, and the barman object name which we will have, and then cluster which we want to restore. So let's run this one. Created, and let's take a look. So recovery is happening. And let's take a look at the, so data stack, setting a primary, so perfect. So let's wait for it to be restored, and then we will see what is there, if it is completely restored or not. So there was an error. Of course, image was getting pulled, and then let's see. Yeah. So see, it tried. Now pod is initializing. Now it is running. So there was an error, but it tried to solve the problem for it. Then again error, something, of course, problem. So again, you have to maybe, yeah, some error, probably it will come up. It's trying to do the recovery, but it will get. So yeah, when it gets up, it will be seeing something like, so this restore, it will be something like this. So if you take a, let's, yeah, okay, and perfect, and like, 13 and 14, right? This is what we inserted while taking a backup. Now data stack is healthy. It came back, right? So if it is healthy, of course, sorry. Same, right? So what we had in source, right? We inserted some data into a table, which is 13 and 14 integer data. When we restored, we recovered it, right? So in any situation, you can always restore. Then we have replica clusters also. You can have a remote replica setup using Cloud Native PG, and in case of any disaster, you can promote your replica as the primary. Right now, that is a manual operation. You have to manually promote the replica as primary, but we have replica also, just to let you know. Then you can do a PITR on this. So for PITR, you insert some data. You have to look for those walls, and then you put the time which you want to. So there's an example on how you do it. Yeah. So if you see recovery target, you have to define the target time, and then it will be restored as a PITR, point in time recovery, right? So we understood all this concept, and the last thing would be to understand hibernation. There's another thing which we have given in Cloud Native PG is cluster hibernation. Let's say you're not using it, so you'll always love to hibernate, right? So that you do not pay for anything. So let's hibernate this cluster. And it's just the command. You can just quickly do it by command. Annotated, and then this all will be gone. Terminating, see? Nothing. Where is the pod gone? Nowhere, right? Gone. It is hibernated. Let's see the PVC. Of course, PVC will be there, right? Otherwise, we'll lose data. So we just removed the pod, which was running as a load. We kept the PVC, and then quickly, like tomorrow you decide, okay, we want. So you can always go and remove the hibernation again. Then again, if you take a look at the pod, it will start coming up. Perfect, right? Beautiful feature to go with. Yeah, so it will come up on its own whenever, like, we can take a look. Yeah, so number 3 is coming, and then it should be number 5. So this one is fast because image was already present in the node. So I'd suggest you to have your images loaded on those nodes so that you have a very fast spin up of clusters and all. But anyways, it pulls, so don't have to worry about it. Now it is up. Okay, so shared buffers. Let's take an example of kget. Let's create another cluster and then define the shared buffer inside it. So this is let me get rid of this one, and also this one. I want like really basic thing. 1. So k create ns and shared, and then we go to that namespace. Perfect, and then we create the cluster. Okay, it will quickly come up. Then you will understand the Postgres configuration changes, which is like comes in day 2 operation. So like those things are important, right? You know, in production, you saw something is not working, then you always go and change configuration tune. So observability important, benchmarking is important, right? Monitoring is important, and then so does your like tuning. So we gave these parameters tunable, so you can go and change, and based on your like requirement you can change. So we'll try to understand put and see what is happening to the cluster. We still have time, right? Just in time. So like just 1 minute and we'll be over. And it was good that we like carried the questions throughout. So yeah. Okay. So running. Perfect. So it is basic. Probably let's edit it directly. Again, we are supporting Kubernetes native APIs, so you can edit and change some parameters. So let's take a look at Postgres SQL. So these many, like I said. So you see there is no shared buffer. So let's add it. So you decided to have the shared buffer. Let's have it. Why not? Perfect. Perfect. So let's say 100 MB probably. That again based on your requirement you can have those. So if you see number 3 is getting restarted because that is a replica. It will not touch the primary. Now number 2, right? And then done. And then we log in and see if the values is updated or not. Perfect. So 100 MB, this is what we defined, right? And then you can also, let's change the value again. Let's say another problem happened, like you do not really want those cache. Now you want to decrease it, right? And assign it to something else. So you can go and where is the shared buffer? Yeah. So you say now I need it to be just 50. Again, same thing will happen. Same thing happening here because we changed the value which requires a restart. So there are values which requires a restart, but there are values which do not require a restart, right? Running. So let's, yeah. So then we 50 MB. Perfect. Now, yeah, if we have time, we can have like final questions, but I wanted to show the upgrades also. We have integrated a major version upgrade. So let's take an example. It will be really, really quick. I wanted to show this one. So in upgrade, I take a like image which is 16 and we upgrade to number 17. So let's do it. And let me have this instance 1 so that it will be really, really quick. Perfect. Pending, it should be up, pod initializing, and then completed. Let's upgrade it to 17. So upgrade, we integrated the upgrade feature of the Postgres with Cloud Native PG. You just have to change the image, that's it. Operator will take care of it. And so I created this one. So let's say again change it to 1 and -1. So this one is 3. Now see the YAML definitions. That's how you do it. The same YAML. If okay, let's take what was the cluster example. So we have to keep the same name. Perfect. Same name but different image. So if you apply, it will say it has configured, right? That's how Kubernetes work. So let's upgrade. But before, let's take a look. Then do show version, typical thing again. Oh, sorry. Why? What is the... Let's take a look in the... So what image we have? We have the 16th image. Perfect. Let's upgrade it. So K... Perfect. K get PO. So it creates a tag. So it deletes the previous pod, creates a hyphen tag that it is upgrading, and then if you see, it is saying we are upgrading the Postgres major version. Earlier it was just minor version, but we have integrated a major version upgrade also for the, like, if it is available, why not? That's an important thing, right? Sorry, I'm not able to hear you properly. If you can. Yeah, yeah. Yeah. Yeah, so let's take a look. Describe cluster. Now it has this image and then done. Then done. So how it is done? Let's take a look. So if you are asking question around this, probably you can take a look. This is what is happening in the upgrade. Say in perfect. Oh, I was doing a like select in the small. The select is in the capital. So okay. Sure. Yeah, that is it. Probably we reached to end of session. Thank you for staying and looking at this beautiful thing. You can always connect with us. I will leave this thing here. If you want to, if you miss the chance to connect, probably if you want to, you can connect with me and John. And if you have questions, we are around. You can connect with us. And thanks for staying and listening to me. Yeah.
Окей. Започваме. Следващия лектор ще бъде първия за деня. Хубавото в фал старта е, че няма думата фал финал не съществува, така че благодаря ви, че останахте. Дълъг ден беше, уморителен. Затова ще се опитам да спестя от времето колкото се може. Не знам дали си спомняте сутринта, когато говорихме, имаше един слайд наречен "Няма бекъп, защо?" И той не беше случайен, имаше какво да се говори по него. Главната идея беше, че не направих бекъп на тестовата среда и тя си замина по едно време. Съответно, отново с импровизация сесията е приготвена, Deep Dive сесията е приготвена в последния момент. Двете инстанции, които виждате на екрана, сме ги създали преди 7 дни и са използвани за първи път днеска. Така че ще ви покажа нещо, което виждам аз за първи път и тестваме в продъкшн отново. Нещо, което не трябва да правим по принцип. Сетъпа за днес, както знаете, ще сравняваме перформанса на PostgreSQL 17 и PostgreSQL 18, който беше релизнат преди около по-малко от месец. И преди да започнем, искам да проверя колко от вас изобщо са се докоснали 18-та версия на базата с данни PostgreSQL. Двама, любопитни имало. Единствената среда, която успях да намеря в Cloud и да подкарам бързо виртуална машина с Postgre в Production, беше на... Даже не знам как се произнася правилно името на компанията. Благодарности за тяхната за труда им, че са направили така, че тази база да бъде available веднага след като е релизната. Сетъпа за днес най-ефтиния възможен. Едно CPU, 4 GB RAM, 80 GB хард диск, 18-та и 17-та версия с дефолтни настройки за memory, както ни ги подава Cloud Provider в момента, в който си я създадем. Никакъв тунинг, никаква оптимизация, едно към едно. Деплойнати са в европейски дейта център. Мрежата, която ще ползваме е една и съща, тази, която използвам локално на компютъра си. И това, което ще направим е да стартираме един скрипт срещу двете версии. И този скрипт да налее информация, да започне да селектва от тази информация и накрая да сверим тайминга между двете версии. Като, пак повтарям, това не е правено дори от мен до момента на тази среда. И аз ще бъда изненадан приятно или неприятно от скоростта, с която 18 ще се представи пред нас днес. Какво представлява скрипта, който генерирах? Добре, ще опитам. Днес Command Plus не става на то BB Edit. Ето това ще е поредния. Аз ще ви го прочита. Значи, наливаме 2 гигабайта данни в таблица, след което и създаваме индекси на тази таблица по един и същи начин в двете системи и след което почваме да правим select count звезда, select count звезда с филтър по индекс, select към две колони с филтър по още един индекс и след това апдейтваме вече данните. Тоест апдейтваме с филтър по индекс, изтриваме редове и така нататък. И накрая приключваме с vacuum verbose analyze и дропване на схемата. Операциите ще бъдат описани в резултата. Това, което ще направим е заедно да ги провериме и да ги сравниме. По принцип не ви препоръчвам да правите така като мен. Connect стрингове на запис с пароли не, но това е тест продъкшн среда за мене. Да, и си я споделям. Избираме си бяла конзола за версия 18 и стартираме скрипта и си избираме черна конзола за версия 17. Няма лъжа, няма измама, пред вас се случват нещата, каквото покаже сравнението и състезанието, това ще бъде. Ако се окаже, че версия 17 е по-бърза, ще бъде доста интересно. Така, 2 гигабайта може да проверяваме междувременно какво се случва в нашите базички. Очакваме така повишение на ресурсите. 18-ката все още си стои стабилна. Тук вече започва да има пикове. Така, CPU-то на това е версия 18. При екзекюшъна си върви в диапазона 70%. Сега ще го изчакам още малко да покаже дали ще има разлика. И на версия 17 тук ми се струва, че доста по-сериозно CPU утилизация има, въпреки че пуснахме скрипта малко по-късно. Пак казвам, че в тази сесия се забавляваме. По принцип, причината за да има този Deep Dive е, че оригиналният лектор просто се отказа заради ангажименти в службата си и слота беше абюзнат от мен. Така изчакваме. Може евентуално да сравниме някакъв чекпоинт. Сега мога да кажа на първо четене, че 17-ката ми струва малко по-бърза в Data Load. Ще разберем накрая. Започнахме създаването на индекси. По принцип, една от големите оптимизации в PostgreSQL 18 е точно начинът, по който работят индексите и индексирането. Може би това ще ни даде голямата разлика вече. Окей. Проверяваме как се държи белия екран. Тук мисля, че вече имаме един победител в лицето на 18 по отношение на индекси само. С малко. Шест секунди по-бързо е при създаването на индекси тази база. Сега ще е интересен вече селекта при наличието на тези индекси, които работят по-оптимизирано. Осемнайсет е по-бърза с 6 секунди при създаването на индекса. Имат и Microsoft Azure, но не е в продуктивна среда. Тоест хората, които промотират този клауд, казват, че ви може да си го използвате за продуктивна система. А другото е в превю. И GCP и Azure. Аз съм избрал тази, да видим. Така, на коя стъпка сме? Създава се последния индекс в момента. Първоначалният план беше да пусна 20 гигабайтов лот, обаче прецених, че няма да запълвам целия слот на сесията, защото има и други интересни лекции, които може да посетите, като една от тях е светът на PostgreSQL екстеншените, където един от основните контрибютори в създаването на PostgreSQL софтуера ще разказва за тези екстеншени. Интересното при тази сесия е, че в България при наличието на всичките тези програмисти, дейта инженери, SRE екипи и така нататък, няма нито една линия contribution към source кода на open source базата PostgreSQL. И това мечтая да бъде променено в следващата 26-та година. Така че интересно е, екстеншените може да си ги създаде всеки и да си използва подобрения към средата, която всъщност има. Така, да видим докъде са стигнали нашите скриптове. Все още създаваме последния индекс, явно той ще е най-тежкия. Във втория индекс 9.17 версия го е направила за 9 секунди, докато 18-та версия го е направила за 6. Отново е по-бързо 18-ката при създаването на индекса, което показва значително по-добър перформанс, около 30% при read операции или storage операции. Честно казано, сега ще ми е интересно да видя вече как изглежда графиката. Окей, версия 17, макси утилизация 92%, настояща е около 58% при създаването на последния индекс. Да видим как се държи 18-та версия. 100%. Сега ще си кажете, да, окей, защо? Но, както знаете, CPU, когато имаме на сървъра, ние искаме да си го ползваме, плащаме си го и защо да ползваме 70%. Аз искам да ползвам 80%, да. Удрям лимит, 100% ми е CPU-то, обаче до момента времето, което показваше базата с данни при създаване на индекса, беше по-бързо. Проблем с CPU-то бихме имали, ако нямахме горен лимит или точка, която да ни ограничи, и това би генерирало една огромна фактура в провайдера, който ползваме в случая. Така, сега да видим метриките. Disk Space Usage, той не се е променил. Disk I/O. Reads per second. Отново сме ударили на 100%. Това е 18-та версия. Нека да погледна. Ще опитам да го отворя на втория екран. Тук доста по-сериозно I/O има, като read операциите са с около 30% по-високи, т.е. IOPS лимита, ако беше сложен на 285, нашата инстанция би го ричнала. Тук сме с доста по-сериозно I/O. Това също е нормално, тъй като казваме, че в 18-ката IO-то вече е паралелна операция, т.е. асинхрониус. Добре, нека се върнем на втората метрики. Коя друга метрика ни е интересна? Memory usage. Сега за memory ще бъде по-интересно, когато започнем да селектваме от тези таблици, защото знаем, че бързите read операции се случват в паметта. Но за мен 18-та версия би трябвало да е приключила с този индекс. Нека провериме. Да. Какво е това? Да, 6 минути и 14 секунди. Нека видим 17-ката. Докъде е стигнал. За момента изпреварва според мен, защото 17-ката свърши теста. Докато 18-ката все още вакуумира. Така че клейма за speed тук е failure, обаче аз ще ви кажа защо е така. Вакууминг процеса на 18-ката със сигурност ще бъде много по-бавен, тъй като сториджа, който аз ползвах за него, е втори пореден опит, т.е. би трябвало да има някакъв процент от dead тупли, които са останали неизтрити. И затова до вакууминга ще е времето, което аз ще акцепна като разлики. Самия вакууминг няма да го броя в това сравнение. Окей, имаме финал и на двете инстанции. Тук съм приготвил една команда, която не зная дали ще сработи, да видим, за да прочетем разликите. Окей. Аз ще ви чета времената, защото съм много древен шрифт, просто ще загубя много време да го увеличавам. Създаване на схемата и таблиците. Взимам тази част от теста. Отгоре версия 18. Долу е версия 17. При създаването на първата таблица доста по-добър перформанс на 17-та версия. Така че тук ще трябва да се намери причината. Затова със сигурност ще я проверя и ще пусна един документ малко по-късно, може би следващата седмица, за да знаем каква е точно разликата и защо в тази фаза 17-та версия е по-бърза. Така, минаваме на следващата стъпка, която е инсъртване на 2 гигабайта данни. Това е 17-та версия. Отгоре трябва да дойде 18-та. Тук вече по-добър перформанс от новата версия на базата. Storage IO-то си дава отражение, утилизацията на максималните ресурси също и сме изпреварили с около Сега ще ги сметна 21 секунди при наливането на данните. Създаването на индексите. Тук също е включено доста storage I/O при създаването на индекс. Това е тежка операция с ридове. Малка минимална разлика, обаче в големите индекси, т.е. последния, който е по няколко колони, 17-ката се е справила малко по-добре. Даже не малко, ами доста по-добре. С 2 минути по-бързо. Сега ще ми е интересно да сравним фул скановете. Окей. Седемнайста версия 13 секунди на Full Table Scan, 18-та версия 18. 30% по-бавен резултат за 18-та версия. Ние казваме, че мериме on the go. Това нещо и аз не съм го правил, не знам какви ще бъдат резултатите. Това показват. Average benchmark 7 секунди. Момент. Ползването на индекса, тук това го изпуснах. Пета стъпка е ползването на индекса при селектването. Вече 214 милисекунди. Срещу 1380 милисекунди. Тук говорим за 5 пъти по-бърз сканинг, ползвайки индекса. Тоест, клейма, че индекс оптимизацията в 18 е нещо като голяма стъпка напред, е потвърден с този селект през индекс. Average benchmarking 7 секунди за 18, 8 секунди за 17. Сега average стойностите аз не ги приемам като реалистичен бенчмарк и генерално от бенчмарк до бенчмарк може да има голяма разлика. Ние мериме сега точни цифри. И го има на запис. Сега за апдейта. Апдейтване на данните с 17 секунди се е справил 17-та версия. За 26 секунди се справя 18-та версия. Доста по-бавен при апдейт. И delete бенчмарка. Отново доста по-бавен 18 от 17. Минавам напред в логовете. Vacuum Analyze стъпката. Това ще го взема цялото. Окей. Нека сравним average read rate и average write rate между двете бази. Четенето е с 21 мегабита в секунда на 18 срещу 25 на 17 и еднакви при писане. Buffer usage, т.е. колко пъти сме прочели от memory, сега ще разбереме. ...467 000 срещу 533 132. Сега, тук измерил и CPU-то. На мен ми е по-интересен финалния резултат. Една минута, 26 секунди и 52 стотни срещу 1 минута 31 секунди и 547 стотни. Дропа на таблицата 360 милисекунди срещу 47 милисекунди. В тази среда, в която ние сме стартирали PostgreSQL 18, очаквано или неочаквано, аз не очаквах, но 17-ката се представя по-добре в състезанието. Причината може да бъде неоптимални параметри, защото новите фючери все пак може би изискват различна конфигурация между двете среди. Така че за мен състезанието го печели версия 17 и ще правим разбор защо е така. Благодаря ви много, това беше от мене и ви оставям да се почерпите с още едно кафе и да се насладите на екстеншените.